do this. Alrighty, so today we're going to talk about two types, I think, and then the implications of how the type integrates with the rest of the system. One of them is IAsyncEnumerable, the other one is IAsyncDisposable. And I believe that's the proposal for both of them, correct? That's just the abstractions.
Yeah, so I've got 4 issues here, and I'll probably hop around between them a little bit, but I can provide the overview and sort of highlight how they all fit together. So I'm sure most people are generally familiar with the ideas here, but I'll go over them again. Today we have IEnumerable, IEnumerator, IDisposable, and the language has 2 primary features that interact with them, for each for consuming enumerables and iterators for producing them. But one of the biggest asks we've had around async since we introduced it was the ability to, for example, in an iterator, not only yield, but also await. And if you await, but you only have IEnumerable and IEnumerator, then your move next operation would inherently have to block waiting for any async work that happens in the iterator, which is worse than not having async at all. And so we were sort of going down this path of, right, we'll add async equivalents for the synchronous interfaces we already have. We explored various options for what these things look like. In fact, we got so far that Julian actually implemented the alternative interfaces we had explored in the compiler, and it was sort of a last-minute shuffle to go back to this design. But where we ended up is basically direct counterparts to what we already have for synchronous. So IAsyncDisposable instead of IDisposable, it has a dispose async instead of a dispose. IAsyncEnumerable instead of IEnumerable, it has a get async enumerator instead of get enumerator, and IAsyncEnumerator instead of IEnumerator, and it's got a move next async instead of move next. We have async in the name of the interfaces for obvious reasons. Otherwise, it describes what it does, and we can't conflict with the existing interface names. There was some discussion about whether we would want async in the method names themselves, and I think we primarily did that for 2 reasons. One, for example, get async enumerator returns an async enumerator, so it logically matches between the method name and the return type. And 2, we want to make sure that these interfaces can be implemented on the same class that has the synchronous implementation as well, and not having to implement one of them explicitly. And if we want them both to be able to be implemented implicitly, we don't want their names to conflict. Plus, it's nice if they do that, if it shows up in the public surface area, you see which ones you're calling.
Well, if you get compiler support for duck typing as well, they have to be different names, right?
Well, the language support will, you explicitly specify in the language which you want to use. We can talk briefly about the language features. Today, you can for each over an enumerable, or for each over an enumerable. The language will allow you to add the await keyword in front of the for each, at which point it expects to be given an IAsyncEnumerable. Similarly, at the production side, when you're implementing an iterator, rather than having your return type be IEnumerable and in the body having a yield causing that to be an iterator, you can have IAsyncEnumerable as your return type with the async prefix in front of it. And then you have an async iterator in which you can both yield and also await.
It's true that the for each expansion can be duck type in the sense that it looks for a pattern rather than, and there it kind of needs the patterns for the 2.
Yes, but you wouldn't
be different. Otherwise, the type couldn't expose both patterns.
Except for each isn't going to look for the IAsyncEnumerable pattern, and await for each isn't going to look for the enumerable pattern.
So it looks like there will be like 2 different parallel patterns.
Yeah, but if you wanted a type to implement both patterns,
oh sure, yes,
then then this is having different names.
Absolutely.
Well, only on get async enumerator. They'll be implemented by different struct types, so
sure
they can share
so
without collision.
I was talking with Christoph this morning, and he'll be late, so since this is a question for the beginning of the thing, I'll ask it for him. In the beginning, in .NET 1.0, we had the GC, and it ate things whenever it felt like it. And then people wanted the ability to control that, of saying free a resource right now, so we added disposable, and that means free a resource right now. What does IAsyncDisposable mean? In terms of an object, how do you design it, how do you use it, and do we even need it for this proposal?
I'll attack those in reverse order. A, yes, we need it for the proposal. For the same reason we were talking about before the meeting started. If nothing else, if you if you decide to exit out of your for each loop, your wait for each loop, for example, and the thing you were iterating over had a using block or a try finally, we need to be able to clean up the resources that were explicitly being disposed of, for example, in the finally block in your iterator.
Or abandon them.
No.
Well, dispose is never required for correctness, and if it is required for correctness, we need to redesign the feature.
Well, so why do we have dispose in .NET to begin with?
To allow for people to do opportunistic cleanup that the
Which is
GC should
exactly
always
what
be
this
able
is.
to make.
Well, sure.
Well, I'm just saying, like,
But
you said we need
if you reviewed code, if you reviewed code that didn't dispose it and it was
I'm just
disposable,
making sure that this isn't a functional correctness, that this is a performance and being able to understand your state if you don't have too many things waiting on a background or whatever.
well, there is always a functional argument to if you dispose of if you have some resource that's being used and then you want to use it again and you don't dispose it, you have race conditions, you have functional bugs. And if you don't dispose it, that's a problem. If you rely on the finalizer, yes, your resources will be cleaned up eventually, but not in time for you to predictably use them again.
Yeah, it's not performance. It's you know, predictability, determinism. Right?
I guess yes. Dispose is good for determinism.
Yeah.
But not calling dispose should not put an application into a corrupt state.
Well, not calling dispose could put it into corrupt state, just not in terms of resources being leaked.
Just in terms of handles, not
Being
What's
being
an
closed,
example of when that might occur?
open and close a file and want to reuse it again.
and then the other operation fails because the file is in use, and then your app is in a bad state
Yeah,
potentially.
think about the tree walker for the file system, which implements IAsyncEnumerable and then disposes of its resources at the end.
You execute a bunch of queries against editors and you never close the connection. You run out of time.
But so I guess then the question is, but at that point, you're disposing it. Is there a case that we've come across where the dispose is itself not atomic synchronous? Like if in the file,
Lots of places where
in the
dispose
file
is
case,
atomic.
it's you call fclose or win close file or
You
whatever.
have two
with
files
those
and you
two.
want to dispose them both.
You have a network connection, you need to send a message to close the connection.
Okay, and again, just making sure we think that these are
These are real cases.
real cases and that it makes sense for the end of this using statement to be doing a bunch of network requests. When again, especially once you're designed on the network, you not need to make those requests because the network protocol itself must be fault tolerant too.
It's not even network request. It's you're flushing a file to disk
Okay.
or to whatever. Yeah.
I'm channeling Christoph here based on
You can channel my feedback.
and so I'm just making sure that we're not drawing parallels unnecessarily. So.
Fair enough. The other thing that's interesting from these signatures is they return. When we initially looked at the interfaces, these were returning task and task of T or task of bool. We switched this in our minds and designs around the time we were shipping .NET Core 2.1 when we added some additional support to value tasks. So in general, task is still a much more usable, robust, consumable type than value task is. You can do a lot more with it. You can, we guarantee that you can await it multiple times. You can store it into a dictionary and use it later without fear that something's going to change. In general, with value task, we recommend that it basically you just directly await it, and if you're not going to directly await it, you call AsTask to get back a task, which raises the question, why would we use it in these signatures? And the answer is a fewfold. One, first, usability with these APIs generally isn't a huge deal to some extent because you're consuming these almost always through, not always, but almost always through the language support for each and the like. So you're not even directly awaiting these operations. Second, there's a significant performance advantage that comes with being able to use value task here, and that is with task, if moved next async actually completed synchronously, without the A, synchronously, then we could return a cache task for task of true and task of false. However, if it completed asynchronously, we would always need to allocate a new task that represented the promise that's handed back to the caller for that could be eventually completed. Value task in 2.1, we added the ability to construct it not only from a T and a task of T, but also from an interface, an I-value task source of T. And we can implement, in fact, the compiler does, implement the enumerable that it gives, that you get back from an iterator. It can do the same trick that it does today with synchronous enumerables, where get enumerator will often give you back the same object as the enumerable, give you back this, that implements both interfaces. But we can take it a step further here. We can actually reuse that same object and give it back as the return value of move next async, because this is, it's never valid to call move next async again on an object that already has a pending move next async. So we can repeatedly hand back that same object for the lifetime of the enumerator from every move next async that yields asynchronously, which means for the entire life of this enumerator, no matter how many times move next async is called, and no matter how many times it completes asynchronously, you only have that one allocation for the whole sequence, which is a huge advantage.
So for each, literally only allocates one object in that case?
There might be a second one for a delegate, but yeah.
Well, actually, for each, only allocate 0 objects.
Well, I mean the async version of that.
The creation of the enumerable that you're
Yeah.
for eaching over.
Yeah, because you already have the enumerable when you start for eaching over it. And in the common case, there's not going to be multiple concurrent for eaches. So you only in the case of a second concurrent for each would you allocate a new one for the enumerator.
Right.
So the common case is 0, or when the delegate.
Yeah. Common case, the common case will be 1 or 2. I forget the actual details, but
Like if something is only for each once, the first for each allocated the enumerator, unless it was a struct enumerator and you use the pattern. But yeah.
No,
the thing that created the
it reuses
enumerable.
the enumerable as the enumerator if it's been generated by.
Oh, if it's the state machine.
Yeah, if it's been generated by a state machine.
Yeah, like in link, when you call select, it allocates a select iterator,
Mhm.
and then when you call get enumerator, assuming no one has before, you just get back that same selected iterator instance. So those are the sort of the key details of the interfaces. Then there are a few other pieces here. So if you look at async methods today, for async void, async task of T, async value task of T, etc., the compiler relies on library support for sort of the boilerplate related to the method's implementation. It has these things called builders, which it creates at the beginning of an async method when you call the method, and it relies on that builder to do things around managing execution context, around allocating and returning the task, and so on. So we have one of these for all of our various forms of async methods. While it's possible, and the compiler that's shipping in preview 1 does this, it's possible for it to build on top of the existing types, but it's a little bit hacky, and we feel like it's cleaner if we introduce a specific builder for async iterators, which in its initial implementation just sits on top of internally the other builders we have, but we can change that, and it gives us the flexibility to change things in the future, and it's a little bit cleaner. So if you scroll down just a little bit, Nemo.
Let's get Nemo's back.
Just to clarify, you
Yeah.
said this method builder doesn't expose the underlying one through its public API, correct?
Correct, it's an implementation detail, yeah. And so basically the compiler will call create, get the builder. Every time it needs to push the state machine forward, it calls move next. When it needs to do an await, it uses await on completed or await unsafe on completed, and the builder handles hooking up the continuations and doing everything else. And then when it's done, it calls complete. Technically complete isn't necessary right now, but I've added it in because I believe there will be things that we'll want to do around being able to do some tracing or ETW logging or things, if you neglect to finish your enumeration and you don't dispose of it, you don't do anything, you might want to log like we do with async methods today, as of .NET Core 2.1. So this sits in compiler services. There's no reason for someone to use this directly. It's just there for the compiler.
Are the things in compiler services not painted as editor browsable never, or
They're not.
okay.
And compiler services is sort of a mix of
Yeah.
things that we kind of, in general, we put them there because they're there for the compiler, but every once in a while something shows up there that people end up using.
Just ask.
Like Strongbox is there, and people have use for that in their own code. But this is one I have trouble thinking of a reason someone would want to use this directly.
Just making sure we weren't missing editor browsables and other
I-
please
we,
don't look at me.
we could add it. I don't think it's necessary.
Okay, consistency's good.
There's one other piece that the compiler relies on. So there's the interfaces that generally consumable, but obviously the compiler requires them. There's this iterator method builder that the compiler uses as for boilerplate. And there's one other thing. Could you go to the next tab? Yeah. So I mentioned the iterators implement this interface iValue task source that lets it plug in that same object behind value task. There is a non-trivial amount of logic associated with implementing that interface because basically you have to be able to handle all of the logic around race conditions between someone coming up and hooking up an onCompleted and someone in the operation completing and handling execution context and handling synchronization context and so on. We don't want to have the compiler generate that at all. There's a lot of policy there, never mind into every assembly that it creates. So if you scroll down a bit to the API,
Victor, can you mute? Thank you, Evo.
So in addition, anyone who wants to implement this manually has to implement similar logic themselves. In fact, we have, I believe, 3 different implementations of this currently that we will hopefully consolidate in .NET Core. I'm proposing that we add a public type that handles all that for you. And in fact, the preview one of the compiler uses this today. It just requires you to basically, there's a little CS file you have to include in your project that includes all this stuff, but it'll eventually be in the library. Basically, this type is a struct, and the idea is you put it onto whatever object you have that implements the interface, and then you delegate to this guy from all of your interface calls. And that allows you to have that single object. This handles all the logic, and you just delegate to this for that interface implementation. So the 3 methods on the bottom, get status, get result, onCompleted, those are all directly related to the interface. The interface just delegates to those. The rest of them are related to a consumer interacting with the object. I don't love the name. It's a mouthful, but the idea is a value task source because it helps in implementing iValue task source. Manual reset because it's about manually resetting, just like we have with manual reset event. And then logic because I was thinking maybe we'll have a class version of this that just wraps the struct version, and it would be called manual reset value task source. And so this is the logic behind implementing the interface. But I'm totally open to better name suggestions that I can come up with. The various members here should be relatively self-explanatory. Reset resets it back to be used again. Set result, set exception, complete it with either a result or an exception. Run continuations asynchronously dictates how the implementation handles invoking continuations that have already been registered with the instance when you call set result or set exception. So if you await an object, you're basically giving it a callback to invoke. And then at some point later when that operation completes, should the completion, the invocation of set result or set exception, should that synchronously invoke the delegate or should that queue the delegate to be invoked? And so run continuations asynchronously control that behavior. We have the exact named option on task creation options as well. And then the bottom stuff is all for the interface. So this is the other piece that the compiler would directly depend on.
It's basically like a task completion source, resettable. And
It's a
value task.
resettable, non-allocating task completion source. usable behind value test.
Something we've definitely written a few times
Yeah.
and
When
would be
we
nice
have-
to have.
You know, a method, and then it has its workhorse method. We call the workhorse method core.
Yeah.
So
We could call it
maybe,
core.
Maybe, yeah, I'm just trying to look like logic isn't a word that we use anywhere.
Yeah.
And
Like I said, I don't
engine
know this.
means too many things, and driver means different things, and so maybe manual reset value task source core. And then if we wrote a class over it, it would just hold one of these as a field.
Do you anticipate this to be the primary use of the interface?
You mean, do I?
Like most people using IValueTestSource, the implementation will be this.
That's my hope. There is the other alternative that is auto reset rather than manual reset. I haven't figured out a great way to encapsulate that yet, and my thinking is it'll likely be layered on top of this. The auto comes into play. So there are two scenarios where you can imagine these being used. One is the scenario that we have with IAsyncEnumerable, which is basically there's only ever one consumer at a time. You're not worried about race conditions. The caller comes in, calls move next async, and it is completely an error to call it again before the thing that it returned completed. In which case, you can say that move next async calls reset, and that's fine. But if you take something like sockets, so socket.receive async and send async in .NET Core 2.1 return a value task, and they do something like this so that no matter how many times you call receive async on the same socket, you're not allocating. As long as you don't use receive async concurrently on the same socket. Because receive async doesn't have the same guarantees. It can be used concurrently. Why you would do that, I don't really know, but you can have any number of outstanding receives asyncs all pending at the same time. And so what we do is we basically say, the first one who comes along gets the reusable object. Anyone else who comes along while it's in use, we allocate for them. And then when the first one completes, it basically signals, it effectively auto resets the reusable object such that anyone else who comes along after that can get the reusable object. So that as long as you only have one receive async at a time, you're always using the reusable object, and anyone else who comes along while someone else is pending gets a new one. That doesn't exactly work with manual reset, but I believe we can build it on top. So I think this will be the workhorse.
Okay, if I was thinking if this was the primary implementation, you might be able to make the name simpler. But
What would you recommend? What would you
I was just thinking like you could drop logic entirely, and if the class wrapper is really like a wrapper, then and it's the uncommon case, then that's the one that merits like extra.
Yeah, I
Some
think-
extra suffix or something.
So let me clarify my answer. This will be the common case, I believe, for someone who already has an object that they want to reuse, as in the compiler case. There are cases today where people use task completion source, and in some of those cases, it's not sitting on some other object. They just have a task completion source that they hand the task out and they complete. And in those cases, the class-based version would probably be what would be used. Or they would just implement their own that, if you scroll down, Emo.
Tells me off that the screen is on the right hand side of my monitor. It doesn't make any sense.
Obviously, we need portrait.
So that's the class-based version. And so they would effectively implement that if they didn't need anything other than that struct. You know, passing everything through to the struct internally.
That's the one that's more like TCS in that you can create an instance and just return half of it. And
Exactly.
Yeah.
Unfortunately, I cannot use the prefix value here. It would be confusing. We would have to come up with a different.
Value manual reset value test source. Ship it.
Value.
Value, yes.
Enterprise edition.
2018 preview one.
For business.
Weren't the early 2000s so much fun?
So why don't we keep walking through the remainder of the things, and then we can come back and discuss any further issues. So we talked about the interfaces. We talked about the helper types the compiler will use. There's, can you go to the third tab?
Oh yeah.
So there's
And your stupid enum.
yeah. So, okay. So now
we have the situation where in libraries, we encourage developers to use configure await false because we want to have libraries avoid capturing the current synchronization context, current task scheduler and whatnot. But here, you're not directly awaiting tasks. You're doing, that should be reversed. We changed the syntax. It should be await for each. So you're doing await for each, T item and source. You're not explicitly awaiting any tasks. You have nowhere to put the configure await. If you were manually writing it out like the bottom, which is basically what the compiler generates, you would put the configure await on the e.moveNextAsync.configure await false. So how do you tell the compiler to do that? Well, we can take advantage of the fact that there is a pattern. And so if you scroll down, we can basically allow someone to write await for each T item in source.configure await false by having an extension method on the enumerable that hands back a struct-based set of APIs that implement the pattern and that internally end up using configure await.
Interesting. This means that if the thing that you're, if the thing that's inside of the for each statement is a struct, it's going to be boxed by this configure await call, correct?
If the thing, if source is a struct,
If source is a struct,
that will box it.
Okay.
Yeah.
So I noticed that this takes a bool called something complicated that no one understands. And having last night read the section of framework design guidelines that talks about Boolean parameters, I have to recommend that we add a two-value enumeration for this and then change the existing API to also take one. AKA the thing you wanted, Steve.
Because there may be more than two values in the future?
No, because no one can read what the code says.
Oh, well, you can now use named parameters. It solves the problem.
It makes a different problem.
So you just write bad code for me.
Okay. It's your blood.
I am
Yeah,
whatever the room wants.
we can leave that as different. Just I hate configure
So
await
can
false.
we, while we at it, can we solve this configure await problem kind of holistically for both? Because it seems like you don't like the current situation, but yet this proposal kind of keeps going with it.
Method impl.
I don't have a good answer.
I mean, what would the alternative design look like is the question.
Well, I think the number one recommended thing on the Roslyn repo is give me a assembly level, do the thing Steve wants attribute.
Well, but that
and
goes
Jared
back to-
says no.
Method impl options unsynchronized. We have synchronized.
I don't think the language design is interested in solving
Yeah.
configure await at the moment. At least not something that we've put on the table.
Because it would be, so the thing that would, let's say there is never a solution, we never solve this problem. Sure, we just keep going. It would be kind of unfortunate if we use configure await false here as an extension method, and then next iteration came up with a solution that actually addresses the problem in a nice way. Because we would kind of now have legacy in both places.
So we don't have a solution in hand that would address this in a nice way.
I would argue that the amount of legacy this produces is very low.
I am not 100% sure. Like, as we move into more and more kind of library code, basically the question is, you know, do I now slap configure await false on everything that I call, which I think this is the do what Steve says, this attribute.
No, but like my argument is different. Like I mean, there's two sides to this. What does your code look like, and what does the framework look like, right? For better or worse, the framework today already has configure await, and the vast majority of people writing asynchronous code today don't use it, and then there's the other population that uses it aggressively, and their code bases just suck, right? But I think the question is, so if we do this here, so we add like what, one method and effectively one struct type in compiler services, which realistically nobody actually cares about. So if we actually solve it holistically, I would also argue we have to solve it for both IAsync blah plus the plus the normal task situation.
That's what holistically
But I think it's an orthogonal feature. Like I would not tie them together at the hip because that makes it even harder to ship this feature.
The way that this is implemented currently means that you're almost always going to end up having an allocation inside of your for each. And even if the input source is itself a class, its getEnumerator method is probably implemented as a struct.
No.
IAsyncEnumerator.
No, it's probably implemented as a return this.
As what?
Return this.
Oh, return this.
Okay.
If it's generated by an iterator.
Like I would expect that 99% of implementations of the enumerable would be implemented by the compiler.
Okay.
And all of those are effectively return this. And if someone was implementing it by hand, they're probably going to do the same thing. If they're not going to save that one, they're probably also not going to save the one per move next to async. And that's the one that would allocate even more.
So what would the signature of that getEnumerable or enumerator method look like? IAsyncEnumerator, would it return IAsyncEnumerable T?
IAsyncEnumerate.
So
The-
enumerator.
Is there a marker somewhere?
Because I'm thinking back to like list of T, right? That when you call getEnumerator returns a custom type. So what would this look like in practice for those types?
Class compiler generated iterator.
Yeah.
With its unspeakable name or whatever, implements IAsyncEnumerable, IAsyncEnumerator, value task source, and whatever else, and it's IAsyncEnumerator get async enumerator method. With some synchronization does that.
Right. But like my source is not going to be class compiler generated enumerable, right? My class is going to be like database.
Well, your method is going to be is most likely going to be IAsyncEnumerable foo,
Right.
which does await blah 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 and yield blah blah blah.
Okay. Okay, so foo async will return the interface IAsyncEnumerable of T as opposed to a concrete type.
Yes.
Okay. Yes.
I misunderstood your question. Yeah.
But
I phrased it wrong.
it sounded like there was also, or maybe I have the Boolean in my head wrong, that there is also the enumerable pattern matching on
Yes.
this one, which means that you could do, if you wanted to write this the long way, you could do the struct-based thing, and then this will box your struct.
Correct. Yeah, if you were to call,
Well, you could write configure with yourself.
yeah,
Yeah, but
Which is-
for what Steve said, that sounds pretty uncommon.
I expect this is not easy to implement manually. You can do it, but I mean, look what it takes to implement a decent IEnumerable today manually. The state machine is non-trivial amount of code for anything other than something very simple. And it's even more for the async version because you're having to deal with async continuations and the like. So I doubt we'll see, maybe 5% will be manually implemented, 1%, but I think the vast majority of implementations will either be ones that we provide or that system.rx.link or systeminteractive.link provides, which will mostly be implemented, I expect, using this, or ones in the wild that are implemented using the compiler.
Did we sign off on pattern for each?
I guess that's a good question. I thought we did, but maybe not.
I know it's not implemented in the compiler, but I didn't know if that was like just Julian didn't get there or.
We just didn't get there.
Okay.
If we didn't support the pattern, this whole configure await thing dies. You'll notice as well, if you could switch back, that I explicitly don't implement the interfaces on these structs, because if you were to use it through the interface, it wouldn't do what you wanted.
In what sense? What falls on the floor?
Well, the key here is that when the compiler binds to this by pattern and it ends up generating the code that does await move next async, it's actually awaiting a configured value task awaitable, which does the relevant thing regarding the configure await. But if you actually used the interface, if you like did .configure await .select async, something that took the interface, that interface call would be going to the thing that just returns value task source, or value task, not a configured value task. And so it basically becomes a no-op, an expensive no-op.
So this is about how somebody writes one of these methods, but with the configure await problem, inside someone's awaiting and yielding code, are they awaiting configure await false everything they do, or does this wrap that and they don't need to do that?
They're awaiting configure. The await code that they write inside their iterator is just like await code they write anywhere else. They're configuring awaiting. If they're in a library, and if they're in a generic library that can be used anywhere, if they're in a generic library that can be used anywhere, they're using configure await false everywhere. If they know they're only running in ASP.NET where there's no context to be concerned about, then you can issue all that stuff. Okay, so let's keep going through. The next one I want to talk about highlights some of the issues that I face. So I've implemented all of this in 2 PRs, one in Core CLR and Core FX. For the most part, it went very seamlessly, with one exception, and that is there's some real weirdness around IAsyncDisposable. So let's go to that last tab. Yeah. So I went through the BCL and looked at everything we have that implements IDisposable. And the vast number of places we implement IDisposable, there's no value in adding an IAsyncDisposable because the work is closing handles and other things where there's no async work being done. There were basically 5 places that I found, some of which were abstract classes, so there's more building on top of that, but basically 5 types that I found where this was relevant. And you can scroll down. So it's these 5. I'll start at the bottom and work up because that's easier. So cancellation token registration, there's no problems here. Basically, the cancellation token registration is given back to you when you call cancellation token.register. And the idea is you have a callback that'll be invoked when cancellation occurs, and when you're done with your operation, you want to unregister. And dispose not only unregisters, but if your callback is currently running, it blocks until the callback completes, so that when dispose returns, when you're done with your using block or whatever, you are guaranteed that whatever resources your callback was interacting with have either already been dealt with or will never be dealt with. And this is critical for something like, let's say you were returning a connection to a connection pool. It would be really bad if you weren't guaranteed that you return the connection to the pool, and then 5 minutes later, when the cancellation token had cancellation requested, the connection that is now totally unrelated to you and is being used by someone else got shut down. So
never had those kind of bugs.
The problem is dispose blocks, and so we can implement a dispose async where, in that rare case where your callback is concurrently running, we can asynchronously wait for it to complete. Timer is similar. Timer provides a dispose that takes a wait handle, and basically that wait handle will be signaled when the timer has been unregistered and when any callbacks the timer had launched have completed. We can provide a dispose async where you can just await dispose async, and you're guaranteed that when that await is done, the timer is unregistered and no work associated with it is still running or will ever run. Those ones are easy. Now I'm going to jump up to the hard one, which is stream. On the surface, it's pretty straightforward. We implement IAsyncDisposable on stream. We do so by adding a virtual dispose async, whose implementation on the base class just does task.runDispose. So if you don't override dispose async, if you have, if you start running on a new version of the runtime that has this and new compiler, but you haven't gotten around yet to adding dispose async override, when someone uses dispose async, it'll quote quote do the right thing and it'll invoke the dispose method. It may just be slightly more expensive than you would otherwise like because we're queuing a work item to call your existing dispose.
There's the alternative, which is we just have it synchronously call dispose, but that could be very confusing for the caller. And then we go and override this on all of our streams throughout CoreFX and ASP.NET where it's relevant. So for example, MemoryStream, where it is fine to call dispose synchronously, just does so. FileStream, where its dispose currently does synchronous flushes, even if it's opened the underlying file for overlapped I/O, we now use flush async instead of flush. And so on. A wrapping stream like deflate stream or gzip stream, they end up calling dispose async on their underlying stream rather than calling dispose on the underlying stream, and so on. The main difficulty here has to do with how you deal with a base class. Let's say you've got, you're deriving from stream, and you don't know what the base stream's implementation does. Well, with dispose today, the assumption is every level of the class hierarchy may have some resources that need to be disposed, that need to be closed. So if you're A and you're deriving from B, in your dispose method, you release your resources, and then you call B.dispose to release its resources. But you do that here. You're A deriving from stream. You do your releases in your dispose async. You await stream.dispose async, which in turn queues a work item to call dispose. So now you're disposing yourself twice, which in theory should be fine. It should be idempotent, but it's weird. You're calling yourself twice when you meant to call yourself only once. So you could say, all right, well, if I'm deriving from stream, I know it's base behavior, so I'm not going to call base.dispose. But then what if I'm class D deriving from A, deriving from stream? Now class D needs to know whether or not it should call its base, and presumably it does, but maybe not. So for example, I mentioned MemoryStream. MemoryStream's dispose async overrides the base to basically be no op. But MemoryStream isn't sealed. So Levi's MemoryStream, he could have derived from MemoryStream and overridden dispose to not be a no op. Because he's, interesting like that.
Something to do with UTF-8, probably.
Yeah, exactly. At which
My
point,
dispose method called shutdown.
It's
At which
Levi's
point-
UTF-8 memory stream.
at which point, if MemoryStream's dispose async was implemented as a no-op, it wouldn't be calling Levi's important dispose. So MemoryStream's dispose async needs to do a check. It needs to say, if this .get type equals type of MemoryStream, no-op. Else, delegate to the base so that task.run invokes dispose on Levi's MemoryStream.dispose. But now if you derive from MemoryStream,
You have to do the same thing.
you have to do the same thing. You derive from MemoryStream and you override dispose async, you have to know what MemoryStream's implementation of dispose async does, because you can't just call base.dispose async, because it's going to say, oh, I'm not a MemoryStream, I'm a derived MemoryStream. Let me call base.dispose async, which calls task.run, which goes back and calls
Hey,
dispose.
Levi, seal your class.
Yeah.
I actually seal all classes by default.
Which is why we should have a framework guideline that says
Yeah.
seal all classes by default.
Yes.
If only the two people who are theoretically working on the next version of the
Well,
book agreed on it.
the guideline says...
I say seal them, he says don't.
No. The guideline says seal all members by default, which would solve that problem as well.
Sure.
So the guideline is correct.
Okay.
So if stream was a new type and it was doing this from the beginning,
If Stream was doing time was doing this from the
we would
beginning.
make the async dispose async. We make it abstract and force everybody to implement it, and we wouldn't have this problem. So this is a problem of trying to add this after the fact and give it, and not force people to, not break people's
Yeah.
existing implementations.
And there are other variations. If you scroll down,
So data annotations have the same problem, I believe, when it shipped in 4.0. What they ended up doing was just putting a field in the class that said, I'm about to make a recursive call. Someone failed to override something, die.
Hey, Emo, are we allowed to introduce breaking changes to the stream hierarchy as part of a major version?
Yeah, in .NET 5, and it's not my problem, you.
Keep scrolling, Emma. So dispose async.
Was text writer just the same problem but different?
Text writer is the same problem, just not as comprehensive because they're very. It's basically the same problem.
Yep.
I'd also love to take this time to put a stake in the heart of the disposing pattern, because no one should be writing finalizable objects in 2018.
That is true. That is a guideline that should be updated.
Why do we need to implement IAsyncDisposable on stream
Right.
to begin with?
Do it on your own stream.
There are streams like FileStream that flush. There are streams like the deflate stream, which defers. It's got some final data remaining, and it needs to do a write to its underlying stream.
And you're worried that that somebody will have a static stream type, not a file stream. Like it's not good enough to implement it on the file stream because they won't be able to using async or await using the thing because it'll be a
They won't be able to put their
underlying.
stream in a using block, yeah, or a wait using block. So that's one of the options. Is number 2. Don't implement the interface on stream, but implement it on derived types.
And let people do opportunistic casting, or they have a strong type reference.
Yeah.
Is there an in-between where you have introduce a new base class in the mix that's, IAsyncStream or something like that, that adds it, and everyone who can make sensible use of it derives from that one instead?
Yeah, I don't think it's a good idea, but I don't think it solves it. So we would have to introduce that as a base class for FileStream, DeflateStream, and so on,
Yeah.
which aren't sealed, and the problem then still exists for their derived. Unless I misunderstood this.
No. So essentially a direct derived class from stream that's called AsyncStream, and that adds support for the IAsyncDisposable
As
support
abstract.
as an abstract. And then we implement it on every, we take everything where it makes sense and shove it under there,
Right.
implement it, and everything else stays the same. It stays in the synchronous world. It doesn't try to pretend that it's.
So that would work. We still run into the issue that you're given an arbitrary stream, you can't use it with the wait user.
You'd have to switch to using
You have to-
async.
Yeah, you'd have to do a runtime type test saying, is it the async one? If so, I'm gonna.
Well, the biggest problem, would it mean now all framework APIs that take stream would need to take this base type?
Or they need to type check before
They
they
need
call
to have
dispose
to,
async.
Like that feels like it.
Well,
would
only if they want to
introduce-
do async disposal.
Yeah, like I'd be concerned that introducing the new type would then, let's just, as things evolve, someone will take that as a parameter instead of stream, but somebody who already had a custom type that needed to extend, like they were extending some other third-party stream implementation of something, they have no way to insert the base class.
We offer a wrapper that does exactly what your base implementation does, which calls dispose inside of a test run. And that's how you adapt an old clunky synchronous only stream to the new paradigm.
Stream.asAsyncStream.
Something.
So
Why would we not
task
just
run
make it
implementation, we
and
made
make it
in the
through
past.
otherwise?
Sorry, hold on, Jacob.
Yeah.
So like imagine you have like the same with can read, right? Can read, can seek. You just say can dispose async, and then returns false by default, so it blows up if you call it. And so when you're wrapping a stream, you ask whether it supports it, and if you, then you call it, otherwise you don't.
I don't
That's
think
like
we'd want it.
worst.
The dispose isn't
Well,
allowed to throw,
what is
assuming
it?
that we maintain dispose semantics.
So I derived from FileStream.
Right.
Is my and I derived from FileStream for the last 10 years. I haven't updated my code.
Right.
What does my can dispose async return?
Whatever FileStream did. FileStream said, if I suppose FileStream will override it and say return true.
File streams will say return this dot get type equal type of file stream.
Right, but so FileStream return can dispose async will be true, but if FileStream didn't delegate to the dispose implementation of the drive type, it would miss out on the behavior of the drive type.
Because it's the same problem as before, because you have to call the other
But you have something interesting that you've written here where like dispose async could just be flush async and dispose, right? Like, why not just make it not
In theory, yes. Unfortunately, there are cases where, and I believe DeflateStream is one of these, where flush doesn't fully flush because it doesn't, I forget the details, but something like flush async doesn't fully flush because there's state left over as part of the compression, and
Right.
it doesn't like.
You need a trailer. You need to write a trailer.
And it, and so it doesn't actually. There's still a flush that happens as part of the dispose, even if you flushed async just before the dispose. Now we could say that's good enough, and that little dispose that happens, like you should always flush, and then maybe there'll be another one.
Can we add a new like virtual method, which is final flush or something like that, which if you override it, then this is your opportunity to do like an honest to God final flush before we call this.
And if you do anything else after that, it's an error.
Yeah, basically. And by default, it would be an async method that just returns a completed task.
And then we don't implement dispose async on stream, and we just say you have to flush async before you dispose if you
Well,
want that behavior.
you could have a dispose async method. It would be non-virtual, and it would call flush async, flush final async dispose.
We can
Just
have
for
it
convenience.
be
Just like you
non-virtual.
have
I see.
written here.
I see.
If flush final async just calls flush async by default, then you don't need
You
to
could-
also
you
call
could do
flush
that
async.
too.
But
But the key part about it is like this is the last flush that's ever going to be called.
That's interesting.
Basically, just create a whole new protocol for async completion of a stream,
Yeah.
rather than trying to delegate.
In fact, this flash final async becomes the extensibility point.
Yeah.
Like you have this, non-virtual extension method. It's just like a template pattern. It calls various things inside, and the last one is the virtual method that you can do whatever you want in.
And what does the base virtual do?
If you follow, I think it was Jeremy's advice, the base flush final async, just call return flush async, which by default is probably no on most streams.
It's not bad.
But it seems to solve the problem of allowing stream to have the pattern without breaking every single run.
So then you would never use stream with a await using. You use it just with using, but before the using block ends, you do await flush async. Flush final.
You
async.
could,
No,
you
you
could
can
still
use
use
it.
it inside of an await using
Because-
because it would
because we
still
pre-
implement the.
Oh, right. We'd implement the pattern. Yeah.
So-
implement the
so
But you wouldn't be
the-
able to override dispose async. You'd override this.
yeah, dispose
Final.
async would say, await flush final
Yep.
at dispose.
Yeah.
Yeah.
That's
Return
interesting.
task completed.
Because presumably once you've done a flush final, like dispose should just be closing a handle or something similar, which
Right.
should be synchronous in theory.
Right. It is weird of if we're introducing a middle state where flush final's public API and can be, I guess it can be protected, and then that solves a problem. If flush final got called, if we say that's invalid now, like, are we introducing an object disposed exception when no one called
That's
dispose?
interesting. So it probably would be.
So it'd be protected.
virtual.
Yeah.
Yeah.
Yeah, it doesn't have to be public.
And now it's just part of, it's simply the async dispose. Please don't do more work in dispose.
So essentially now there's a new contract on the old dispose, which is don't do anything blocking if you've just been flushed finally.
Which in general is true.
Which, yeah, it seems reasonable, but you could have implementers out there that
Yeah.
do
So-
other,
right.
block on other
So
stuff.
Mm-hmm.
what you would want to do on something like IAsyncStream is have dispose call final flush if it hasn't been called yet. If it has been called, well, you've already written out the trailer, so
There's
do
nothing more to
nothing.
do.
Which means that dispose would still block if it was called without calling anything else.
Dispose
Which is the
wouldn't-
same behavior you have today.
Dispose wouldn't want to call final flush because that would be the synchronous method reaching back into the async world and then closing it back over. So you need to figure out how to handle that in the
Yeah,
synchronous,
yeah.
non-synchronous
But
world.
I think that is solvable.
Do we add both a? Do we
But
add,
someone in their flush final could write like already flushed final and then skip it in their
Yeah,
dispose.
yeah,
So
yeah, yeah.
that's just a guidance, not
but
a,
it's interesting. If we add a flush final async, do we add a flush final as well?
I don't think you have
There's
to
no-
if this is a
there'd be-
protected method.
there'd be no benefit because the existing people who have their trailer or writing trailers in dispose,
They're just doing it there
they're
anyway.
already doing it, and they wouldn't want to go rewrite their code to go take advantage of this. I mean, we could for symmetry, but
Like, I'm trying to think, like, I don't think existing, I think if the only thing you did was add a flush final method that called flush, and then implement the non-virtual dispose async method, I think that would end up not breaking anyone. If that was literally all you did without changing any of the drivers.
So if I create a new Steve's Cool stream,
Yeah.
drive some stream, and I want to implement everything correctly,
So I override everything.
Yeah.
When I override dispose, I don't use flush final async. I just do whatever I want in my dispose. Maybe I call flush, but I don't call flush final async. In my dispose async, I don't override dispose async because it's non-virtual. I override flush final async to either just do a flush async or do whatever else I need to do, such that when dispose is called, it's cheap.
Yeah.
You can't do that.
I mean, you would have to keep track of whether
Because
you
the thing that would
Right.
call flush final sync, for lack of a, to distinguish them, would be base.dispose, but you've already freed your resources before you called it, so you're now dead.
Well, no, I mean, we would say that flush final async would need to.
So flush final async, we'd have a clear pattern on, but if we're trying to also make flush final for synchronous code.
No, we wouldn't have a flush final.
Okay, yes.
Yeah.
Yeah.
Okay, I thought you were talking about adding the
Sorry,
sync
no.
and
I
async.
was talking about if we just add a protected virtual flush final async, how I implement both the synchronous and asynchronous code as best as possible.
Yeah. Flush final async is, if I have not yet written out the trailer, write it now asynchronously. Dispose is, if I have not written out the trailer, write it synchronously, and then free the handles.
And then base.dispose.
Yeah.
Anyone have any concerns with that? Or think of any reason why this isn't going to work?
I need to see it written down, I think.
Wait, does this pattern work with extension methods, or does like dispose async have to be an async method?
That's
We don't know yet.
What would you like?
Presumably making it an instance method, or allowing extension methods presumably would allow patterns like this to be put on top of existing types without us having to ship new types. I mean, granted, flush final async we're saying is a protected method, so whatever. So we would make dispose async instance as a result of that.
I assume that the language does not currently allow anything weird for extension finding on the current using statement.
Well, I can't remember. We are consistently inconsistent when it comes to whether we allow extension methods to.
We don't allow extension methods anywhere for pattern lookup for the enumerable or dispose patterns.
Okay.
We do for await. So we do for task and we do for task likes, but we don't do that for each or iterator. I think the only conclusion that we got to before in LDM was if we do this, we'd like to do it all at once.
Yeah, we might go through, and when we added extension methods, we never revised the existing patterns to take them into
Right.
account.
But that was on
Should have.
that was on the docket too, for part of the enhanced using was let's make using understand extension dispose, and let's make for each understand extension dispose. The problem being that they're going to happen in different orders for backwards compatibility.
Yeah.
You used to add quotes of the day from design meetings. From this one should be, we are consistent.
Consistently
inconsistent. I love it.
I feel like that's the story of many of my days.
But then you don't have concerns with when we add new patterns to also support extension lookups, right?
Right.
No
And
reason-
with the new patterns, it feels like the right thing to do all up. And when the new patterns, there are no concerns with doing so. It's only that if we do it for old patterns, then
Go my brain.
if there are things that happen, if there's sort of things we fall back to after the lookup, like with for each, for instance, we try to look for the methods directly as a pattern, and if we fail, we go look for interface implementation and other
Right.
things. And now, if an extension method can insert itself in between those, and it couldn't before, now it's a breaking change. Now it starts going to the extension method rather than through the interface dispatch, and different things might happen.
And if you insert it afterwards in the lookup chain?
Right, so we would have to put it at the way end.
Yeah.
Which means it's not just a method lookup. We do an instance method lookup, then we do other things, and then we do the extension method lookup, which we can totally do, and I think that's probably where we're going to end. But it's just a little more complicated than just finding the method and saying, okay, go with that.
Yeah, and we have to decide for current using dispose, it's interface first. So are we gonna but for get enumerator, it's pattern first. But this is a new type. do we do pattern first and say to hell with the previous decision, or do we do interface first for consistency?
I think actually if you're using it's interface only.
It's interface only, which means that if we changed it, it wouldn't necessarily be interface first. And
Wait, there's no pattern. Oh, there's no pattern today for using.
there's no pattern dispose. That was one of the things that was proposed.
Yeah,
And has like
we wanted to be able to use it with rough structs, for instance, but rough structs can't implement interfaces.
So essentially we would have to do it in different ways for different patterns, so we would continue to be consistently inconsistent, just in new and inconsistent ways.
Yeah, it seems we should have rules that are somewhat predictable, right? I mean, I think having dispose and for each do different things is one thing, but having for each and async for each doing different things, it would be worse.
or using and wait using is different.
Yeah.
But does it matter? Like,
Well, at least it's, you know,
like
I mean, if everything
would
would
the
be
average
consistent,
developer care? Because for average developer, it would just work, correct?
well,
Yes, they're implicitly implementing the interface, and the type is the same as the interface.
Yeah, I think that's true. It's mostly for us language types
Yes.
that, we have all this complication because they all do different things in different orders.
Yeah.
In practice, there's just going to be one or two things that work out, and the two things do the same thing anyway under the hood.
But I think that the extension methods is where that falls apart. Because if you put an async, or if you put a dispose on as an extension method, then it will necessarily have to be last in the regular dispose list.
mhm.
But we could presumably do extension methods before interface lookup for async dispose.
It still
And then,
doesn't really matter. If you have the interface, why would you put an extension method to?
Well, you would put it on the type. That people are augmenting existing types to say, like, I'm taking a type that doesn't implement dispose or dispose async. You implement the extension method for both, but only one gets chosen because actually at runtime it does implement the interface.
Oh yeah, because we checked the interface amount.
I think that's right. That might be.
do
I
well.
no, we might be
No.
wrong.
No,
But
we
you
don't.
could convert it to the interface, like if you have it actually. But then, who cares, right? Okay, this might not be a problem.
We can work it out, I think, so it's mostly all right. If it's desirable in general for extension methods to work in these cases, and I think it might be, then we could make the language closer to consistent. At least all the patterns would have all the options. It just would be in slightly different orders.
Yeah, I don't have any particular scenarios in mind right now, but I imagine that there's probably a healthy set of like third-party libraries where it will be trivial for someone to write dispose async as an extension method,
Yeah.
but where those libraries can never be updated because the authors just don't maintain it anymore.
Right.
Yeah, but you can usually get away with it with a wrapper object too. Just the calling code's a little
Yeah, that works.
ugly.
But I think that's similar also with IAsyncEnumerable rather.
Yeah.
There'll be a lot of enumerables out there that could be asynchronously iterated, but the original author's not going to go and slap that on.
Yeah.
Maybe.
So one question about this feature. So today we have different names for async and synchronous APIs. So there's read and read async. If you call read async and you don't put a wait keyword, the compiler kind of screams at you. Here, if I remember correctly, you write a for each loop, and you don't have a way to select, correct, which one.
You do. You put a wait before the for each, so that it's like a wait for each versus for each.
Yes, so you have a way to select by having a different kind of await keyword. So the compiler, there won't be an opportunity for the compiler to tell me. Basically, if I already implement for each, and I have now async for each method, I write for loop and it just works, except it's not efficient and the compiler doesn't let me know.
You mean if you have
And I don't see it.
if you have something that implements both IAsyncEnumerable and IAsyncEnumerable? if you use for each, it'll use the synchronous. If you use await
and
for
you
each,
kind
it'll
of
use
don't
async.
know. You don't know. It's not visible.
But that's the same with, like, I would argue when you call run versus run async, right? They're different methods. If you
No,
call
but
run,
you see,
then
my point was
You're not
that
seeing
you
the
see
methods,
that,
though.
correct? Like you type dot read, and you see, oh, read and read async.
Because you're doing completion on the type itself, and
Yeah.
you get this chance to. That was actually part of the argument for putting the async at the end of the name was so that you would list next to each other in Excel sense.
Well, and you could imagine this being. You could have an object that implemented both interfaces. However, I think the most common case, my guess, is you'll do like for each var x in foo dot blah, and blah will either be get items or get items async. That's my hypothesis.
You're not likely to have a list of T that instance that does both. It's really more going to be calling a method that returns.
For dispose async though, while dispose async is not difficult to write, IAsyncEnumerable is.
well, you can always write the iterator, right?
When you
Good.
say difficult to write, you mean just too many characters, or actually creating the state machine yourself?
No, the latter, right?
Yeah. So like a lot of people implement IAsyncEnumerable manually.
Even that's complicated though.
It's complicated, but it's like no, IAsyncEnumerable is just bad.
So the issue that I mentioned is also, I mean, the same issue exists for dispose, correct? I'm just doing
Yeah,
using.
right.
If I have dispose async and dispose,
Nothing
it
tells
kind
you,
of
yeah.
like
You're not going to get warned that you're using one.
Yeah.
You could,
Would it be
and-
possible for the compiler to detect
Yes.
if we are inside an async method, either automatically select the async dispose or async for each?
I could imagine it being a
Or-
warning. If,
Yeah.
if the compiler could,
Analyze it,
if the
yeah.
compiler, I mean, using requires that the compiler statically sees what it is supported. So you could imagine if you're inside an async method and you had a using block on something that the compiler saw was both IDisposable and IAsyncDisposable, it could issue a warning to say, consider using await using.
I'm not sure if you want to do a warning because if someone's got warnings as errors on and they just update their packages and suddenly new things do,
Was that an
will
analyzer
break
can
your build.
tell you without being a warning?
Yeah, I was going to say an analyzer that can tell you
Yeah, like it
in
seems,
the IDE
Yeah.
could
it
show
seems
it
like
to
the
you.
thing an analyzer should
Yeah,
do.
I don't know if it should be a hard warning because
I wonder if I'm also a little unsure whether it's always better, even if you're in an async context, is it always better to use the async? I guess it would be.
Well, I think that's a guy that we have to
Not once
decide.
somebody can write both of them because while we would hope that they do the same thing, they might not necessarily do the same thing.
Yeah.
So you don't really want I added the keyword async here and why is my breakpoint not firing?
I also have a love-hate relationship with the existing warnings. Half the time, I'm thankful the compiler warned me that I was missing an await on something. Or maybe 25% of the time, I'm thankful the compiler warned me. And 75% of the time, I just say, shut up, and I do var ignored equals blah.
I know what it means to assign a reference type to a readable
So
field.
there's a question.
Discards
There's a
as well.
question. Should we? But definitely we could. I think that there's enough static information that so an analyzer could definitely do it. For instance.
Yeah, the compiler could.
Yeah,
That would
but
be great.
Initially, I was going for can we just do it automatically, but I kind of somebody brought up the point that it probably would be a breaking change.
it would
because
break
of
builds
difference.
if you had warnings as errors.
Alternatively, you could imagine if we were concerned about breaking changes, we could do it only in async iterators, which don't exist yet.
No, but it's all.
But now it's
it
now
makes,
you copy and paste the code and now it behaves differently.
it makes adding async enumerability a source breaking change. Right. It means that if you add it, then somebody's going to warn
who's
that
using
that
you.
that they should be using it.
Yeah.
So it's not so much that it's a breaking change in the language. We are now adding warning waves. We could just add it as a warning that only comes on when you ask for it. But it's that you can break your consumers by adding a better option, and the
Yes.
compiler would twist their arm trying to use that better option.
What I mean, that's kind of the point, right? Like, I mean,
I guess it's a question of how we see warnings versus analyzers.
no, I would go
Built-in
further and
warnings
say, like,
versus
so abstractly speaking, you have a type that implements both. What should I call? I mean, that's true for both interfaces, right? Like, what's the better option? I mean, I think
Which
generally
keyword did they
speaking, I
use?
would say if you're in an async context, you should probably use the async one.
Yes.
And the implementer of the type has to make sure that you do the same thing, except you do it asynchronously, right? Like if you don't do the same thing, then your type is just fundamentally.
Jeremy was asking me a related question yesterday. If you implement IAsyncDisposable on something, should you also implement IDisposable? Like on something new.
Mm-hmm.
I think that's a great question. I think in general, that I would say for iterators, for example, that are asynchronous, it wouldn't make much sense, right? Because you kind of force your consumer to be asynchronous to begin with. So why would they ever call it synchronous dispose? So I think if your type is realistically only be usable in an async context, I think it's fine to only implement IAsyncDisposable.
We don't use IAsyncDisposable in SignWire, but we have the connection object has a dispose async on it today. You're supposed to do try finally await. The idea being we'll ramp up when we got this. We do not have a synchronous dispose.
This is related to the discussion that we had yesterday.
Yeah.
Correct?
Yeah. In EF we have.
Did you
both.
talk to Steve maybe about it?
We have talked about
Okay.
this for 7 years. So probably, but yeah, we implement both on the same object actually on EF core, and it's fine. I mean, right now we implement the interface from IX. But
Yeah, the issue is that in Azure SDKs we wanted the APIs to be only async. No more of the dual sync async and the synchronous APIs just blocking network calls. They brought up an issue that, let's say you use Cosmos DB from EF provider. Well, EF provider needs to have synchronous APIs. How does EF provider simulate them on top of purely asynchronous APIs? Do we have a reliable way to do it without deadlocks and some other things?
that is back to configure await false versus the deadlocks versus the security principle and the current.
Here's a guideline missing, Steve.
Just don't mix code written yesterday with code written tomorrow.
What detail that I think they can hear from you probably, I think that they see right now that the guidance is to just implement the async version of all the APIs.
Yeah, because you see, like, honestly, like, in the past we had this kind of like, we had async operations and they were, they were slightly more efficient. It was kind of okay to have synchronous operations as well. Now you're going like across networks, and it seems kind of weird to have, synchronous APIs for basically what constitutes web services, web clients.
I was gonna say we're in a transition period, but we've been in a transition period for 7 years. So.
You will be forever, I think.
Okay, so getting back to this stuff, the things I've heard that are changes thus far, protected virtual flush final async, potentially different name for manual value reset task source logic, although we haven't come up with one to my knowledge.
Well, I think I just said replace logic with core.
With core. And then some potential follow-ups around warnings in the compiler. It's fine to not implement IDisposable if you're also implementing IAsyncDisposable. Are there any other things that people have seen thus far that make them say, oh, and I'm assuming we'd have a flush final async, not only on stream, but also on, for example, TextWriter.
Yeah, it would be the same upgrade.
Yeah.
So I have a question.
Yeah.
How do you think it relates to the pipelines? So pipelines have kind of model that is a bit similar to this one, where you write, well, one part is not very similar. You write synchronously, and then there's a flash async that says kind of, I'm done. But it's not fully done. I mean, it's not, it's not the flash final async. Is there something when you say, I'm completely done
I don't know.
with in pipelines?
I'm not sure.
Yeah.
Kind of
because
say
complete-
dispose. Do
I
you
think
ever
there's
have to async dispose?
there's a complete method, wasn't
Yeah, there was something
there?
like.
Yeah, I'm trying to remember. It's just not in my head right now.
And I wonder whether basically pipelines would be able to. It would be worth asking David or somebody if they can implement this.
Yeah, there's complete on the reader.
Is it async?
It's not, and then there's a complete on the writer. That's also not async.
Yeah, as far as I'm in an async method, should the using automatically upgrade, my recommendation would be it doesn't automatically upgrade and it's not a compiler warning that very much
You go
feels
with
like
JASCOR.
code review / analyzer of there's a better thing. There's a maybe better thing, but be careful. It might be a different thing. Like
Maybe
you
a
you
suggestion.
write this line of code and you test it before you ship it and blame me.
So it can be, but I assume that we will tell people that the guidance is the semantics should be the same.
Yes.
Correct. It's kind of a bug if they are different.
Yeah.
But we should keep in mind that there's like a decent probability that people will introduce bugs.
Sure.
Like literally,
Yeah.
the aspect of adding async to anything is like, yeah, it's probably
Yeah,
probably a
I
bug.
completely-
You're probably
People are
gonna
going to
have-
implement IDisposable by calling dispose async.wait.
Yeah, like any number of things. So I would say that this is not like a unadulterated good.
Which is why I think something like an analyzer is the like. Oh wait, that would deadlock.
It might be.
I mean, it would deadlock if your dispose async was calling your dispose. Yeah. I mean, no. If you that's assuming you invoke dispose, you call dispose async, and you overrode dispose async and just went up that chain in there. But yeah.
I assumed that it would deadlock and that would be the bug, but that would be the first bug. There are many more to go.
Yeah.
And the bug could be in the middle class,
That's
so
the
none of
easy
your
one to
tests
find.
test that code path. It's the derived type that you broke. So.
I missed the first few minutes of the meeting. I don't know if you brought this up, but how does the IAsyncEnumerable stuff work with link? Should I have not asked that?
No.
We've been talking about this for 7 years.
We're now
So-
adding await select.
So there's two parts to that answer.
Select many.
There is what does the language do around query comprehensions, and there's what API surface area is exposed.
Serve the APIs.
The current plan is that we collectively work to make interactive extensions that already has an asynchronous link implementation. We work to make that a really good implementation, and that's sort of the reference. The interfaces are in .NET, and they provide that library provides implementation. We don't need to also provide the implementation in .NET itself. Library, it doesn't matter where the library comes from. It comes from IAC. That's great. Part of the reason for that is A, there's already an implementation there. B, the explosion that you get in the number of methods, 100 link methods, 200 overloads, and that's only when you have IAnumerable to IAnumerable, never mind IAsyncEnumerable with IAsyncEnumerable, IAsyncEnumerable with enumerable, IAnumerable with IAsyncEnumerable, methods that take multiple enumerables as input, and the combination, the explosion is ghastly.
Yeah. Is there an IAsync variable as well?
Probably.
We're not talking
That
about
is-
that?
But it's probably not that necessary.
Yeah.
Okay.
The query comprehensions, I know Julian wanted to push on it when he was back, and I don't know where that's landed.
This is
He's
also
not back.
This is also the NP complete part of the compiler. So it's not necessarily great. Because if you use a lambda, then it's lambda inference plus overload resolution, which is
So to
sad.
address that, I'll ask the first idea that came to my mind, which is, would we add the async versions of everything that we have in system.link, like an enumerable or enumerator, or whatever type it is, and then add an implicit conversion from IAnumerable to IAsyncEnumerable, because you can always write the state machine going from synchronous to asynchronous, but you can't write it the other way.
So I talked with Julian. I didn't completely understand the first part of your question, but the second part of your question, Julian raised the idea of having an extension method on IAnumerable as AsyncEnumerable. I don't know if he opened an issue for it or not, but
Because then
it's
you
totally
wouldn't
feasible.
need the async to sync and async to async and then like the
Yeah.
explosion, you async to async to
Everything's
async to
everything
async, and then things would just fall in.
Yeah, that could definitely be done.
Oh, so that gets to the question I actually had. If we go back to, we can revisit that too, but if you go back to the one with configure await,
Is that the
sorry,
tab.
the
3?
third tab,
Yeah, what's what you say?
I don't know where to put this extension method.
Scroll up. What is the extension method?
Configure await.
Configure await
The-
that takes IAsync enumerable.
Yeah. Scroll up just a little bit, Nemo. Yeah, right there.
What do you need to make an async enumerable? Is that system, or is it system collections?
Right now, the interfaces are in system collections generic, unless we want to change that.
Because it does feel that if you have that if you are for eaching it, that you want that to be in your scope already. So it should probably just be in the same namespace
So I
as
had
the interface.
2 questions. One is namespace, second is class name. I don't want to take a perfectly good class name like IAsyncEnumerable if we're not going to have a whole bunch of extensions on IAsyncEnumerable, and the second was namespace. So I don't know, what is IX? Where do all of it select async and where async? What type are those on?
I think it's the types, I don't remember, but it's probably something like async. Yeah, the namespace is something system interactive async.
If we could only put implemented members on interfaces, I hope
that'd
there
be
was
nice.
a feature in the works.
And so this, I raised this now because if we were to add an as IAsyncEnumerable, presumably we put it in the same place. Or maybe that would just be on enumerable, enumerable.asAsyncEnumerable.
So IX already
There
has
might be
it,
another,
so
I mean, configure await, I don't know, it seems more connected to where is the configure await method that we have today on task.
It's an instance method.
Yeah, so it sits with task
System
somewhere.
during
Maybe
tasks.
configure await here, the extension method should sit alongside of it.
So the
Right.
same namespace
Because
on
it's
the-
related to the
It's
configure
just you
await.
don't even need, the namespace to use for each on async things. Suddenly,
Right. You may not have it visible.
yeah, it will not be visible, and suddenly your for each doesn't work, but otherwise.
If your method returns a task, you're probably bringing in the correct namespace that contains task. Right?
But you
No,
It's
but
not
you just use for each syntax.
yeah, between var or simply never assigning to a named local, you may not have system threading
No,
tasks
but
that
I
are
mean,
using at all.
your method, which is the async state machine, returns task, presumably. That means you have task in your signature
Right.
explicitly.
So system threading tasks might be a place to put it,
Yeah,
because
system
then
threading
you're,
task
you're probably
should
going to have
be
it in
a
scope.
using declaration.
I see, yeah.
That's true. You do
Generic-
have, you do have a
yeah.
return value.
Yeah, you're
beneath
more
that
likely
namespace.
to include that than the interface, the
Yeah.
IAsyncEnumerable interface, which people generally don't use directly.
So something in the system threading tasks namespace, some class that we put this thing onto.
That would be my suggestion.
Any
And
suggestions
I'm-
by classes?
Like, it's an extension method holder, so you don't need a good name.
Maybe we
No one
can
ever
even
looks at it.
reuse one of the existing holders.
We do actually have a task extensions or something.
Yeah.
Just put it there.
Do we have any
You're right.
do we have any OOP concerns with that? Whether the class is frozen because of framework interrupt or anything? I'm just that's just asking a question.
Yeah.
Only we have 3 methods in namespaces.
Modules. It's right in the DB.
But yeah, I mean we can start with that, and if we find that there's a problem, we can reevaluate it.
All right.
So I would if
then
you already have an extension
We
container,
should consider
in
an
that,
as IAsyncEnumerable separately, I guess.
Yeah, and there's an addition, down that path, there's an additional question, which goes more to the language side, but also the library side, which is the language syntax for query expressions translates into calling link methods with lambdas, synchronous lambdas. So an async lambda has a different syntax in C#, and either the compiler needs to be smarter than we probably wanted to, or there needs to be some syntax indication that you wanted to have not just the stream, but also the query operator applied to it be asynchronous.
Or we
Clearly
say
it's-
query
And then you need,
operations were a
and
nice
then you need
idea,
the
but-
methods that can take.
clearly
an
you just take the
async
3.5 spec
Still
where
doing
it says select. You start over with async select, and you write the feature again.
How-
and
Just use the
How
method.
popular-
wonder why we invest in this.
How popular is the language query comprehension support?
I don't know. I think, I don't know. It's not unpopular. The simple things people use either. Personally, if I get into anything where I need a select many, I use the query expressions instead, because it lets
From
me,
X-
it lets it
from
feel
X-
like I'm for eaching, I'm doing nested for eaching rather than.
Yeah, I've always hated the diagnosability of the query syntax, including when a team I was on, they had a massive performance bug because it generated a go download the entire database and then run a lambda against the return result instead of send the select into SQL. And then when they fixed the bug, they still stuck with query syntax, and I just rolled my eyes. They're just like, oh, if we flip these two things, now it completely changes the performance of this. It's like, yeah, you can't read that. I don't really like this language feature. But that's just me.
For the language side of it, I think the general sense is let's wait and see.
Yeah.
That becomes, people ask for, oh, I need to do asynchronous things all the time in my queries. Like, maybe we should.
On the IAsyncEnumerable front, I don't know if maybe IX already has this, but if they don't, maybe if the primary benefit of it is you're using all the various link methods and you want to avoid the explosion, maybe IAsyncEnumerable is part of that same library.
Yeah, Tim, what about configure await?
So you don't think it's part of
It could be. Yeah.
the whatever we call the thing with the smallest shared framework?
Well, that's what I'm suggesting. I'm not saying we should, but I'm saying we should think about it. If we don't have a bunch of methods in .NET that accept an IAsyncEnumerable, in the core libraries, if we don't have a bunch of things that accept IAsyncEnumerable, then, and in particular things that accept combinations of multiple IAsyncEnumerables, then maybe it's not as relevant. You are going to be pulling in if you're using another library that would benefit it, that library also provides the conversion. Maybe.
How many of the link methods actually take more than one enumerable? It's not all that many. Right? Maybe, I mean, that particular, they already need the duplication. The enumerable ones are already there.
Right.
In our libraries, they are adding all the
Yeah,
IAsyncEnumerable ones. So,
Append,
so the only extra
prepend, union,
Zip.
intersect, yeah.
I mean, there's some,
Yeah,
but
the
it's
majority-
not like the majority.
Yeah, the majority of the explosion comes from not things that take async enumerables, but things that take sync or async methods, like select. It's operating on an IAsync enumerable, and is the lambda that you give it synchronous or asynchronous for the processing of each element. That's where the main explosion came in.
So looking at IX, it doesn't look like they take both. They have a two async enumerable extension
They
method.
have us,
Oh,
async
so that's async, yeah, so that's the one we were just talking
So
about.
And
the,
so everything else just takes an IAsync enumerable, and you have to convert it yourself.
I mean, the question on that would be if there's any trickiness in making the conversion so that it works, optimally with tasks and whatnot, then does that library, if it's not part of our NetCore app, does that now become an implicit dependency for anybody else who would want to do a similar type of problem, or are we recommending that everybody copy and paste the same extension?
Well, that conversion is trivial. That's an await for each loop. That's a for each loop inside async IAsync enumerable of t as async enumerable. For each var x in source yield return. And you get a warning from the compiler.
And then return
There's no
task
awaits in this
completed.
method, but
Yeah.
you're converting your enumerable to your async enumerable. Actually, you can do it even simpler. You don't even need it for each. It's one of the few times where implementing the interface is actually trivial. Move next async would do return new value task move next, and current would call current. So it's really easy. That conversion is easy to implement.
I like it and then there's if this library provides that extension, and then this library provides that extension, now you have the go resolve your extension methods problem. So is this core enough that we would put the extension in the BCL even if we make no use of it, just because it's just setting things up for extension collision?
It feels like maybe a wait
Just
and
ask.
see, but
Yeah, okay.
One thing for the record, I don't know if you guys care about this, but they are probably going to have to also have a copy of the interface for targeting .NET Standard 2.0, and so that we can have something to work with that is compatible with the new interface, and they are going to have to type forward to the one on .NET Core.
right. So presumably, this is a question for you around Net Standard 2.1. Presumably, these interfaces can get into that, right?
We could. I mean, it depends on how big we think the whole thing is, and how we can get it aligned on the timetable. But yeah, I mean, the question generally is for the extension method, for example, do we need to ship this guy? Can we just configure await also goes to IX? Because then we can just say we ship literally the abstractions, and then the implementation is.
This one's different. So that extension method, the other one we were talking about, it's beneficial when you have methods that accept an IAsync enumerable and you only have an enumerable. This is about consuming arbitrary async enumerables from anywhere and doing it in a library safe way. So any library that's for eaching over an async enumerable should be using this.
Yeah, that one needs to be ours.
This needs to live in core, I believe.
So where does the current one live? Configure await.
It's an instance method on task.
Yeah, so the only thing we cannot have a type called IAsyncEnumerable.
Right. That's why I was asking. So I think the current recommendation from the room was namespace becomes system threading tasks, and configure await, or rather, configure await just gets added onto the existing task extensions class that lives in system threading tasks.
And I presume the IAsyncEnumerable is in private core lib / system runtime, and therefore we're not, nowhere in here are we going to get a dependency ordering problem in core. Yeah.
Could we add an extension method that has a shorter name and where I don't have to pass false? That does the same thing.
That's what I was gonna say,
and do
configure
the
wait
same
true.
thing for task.
We could. I did it this way for consistency with the choices previously made, but if we're okay breaking from that consistency and being consistent with
Well,
it.
then we would add it on task as
Yeah.
well, of
I
like
see.
dot, detach from context or dot default scheduler.
Yeah, configure await is not just a pain to have to remember to do, it's also just big and
And you
makes no
you
sense.
don't know what it is other than
Right.
someone on Stack Overflow
And we
told
can
you
add a
add that and
method
your
that's
problem
called
goes away.
async.
It's
I have no problem with it if the-
over-engineered, right? The idea was, there might be several things that we want to configure, and we'll give you you can use named arguments for each of them with sensible defaults, and then
we haven't done that.
we only needed that one Boolean ever. So,
Yeah, but how many people do you see define? You could define an extension method to substitute for your configure await whatever, but I've never seen that.
But I think that's what Christoph's saying is we should do that. We should, if we can come up with a good name very quickly and make it as an extension method for task to forward to configure await false, and then instead of calling this configure await with the Boolean, we just have the detach from session and with no parameter other than the this.
And we are consistent between two models, at least for the new method. And it's simpler, and maybe it has a more appealing name, such that the developer who writes code kind of like, let me think what it does. Let me read some documentation. Because today, almost nobody calls the method because it has such a name that people are like, I don't need to configure anything.
Yeah.
Well, when I was learning async, it was like, oh, this configures the synchronization context. And as soon as I started clicking on synchronization context, I was like, nope, and I just closed the tab. So I don't know if the name's gonna help. It's gonna take you right to the synchronization context, and then you're just gonna have a bad time.
But then the thing on this is it would say it would just start with the easy sentence. Call this if you are a library, and then the big explanation of keep reading if you're Steve. So.
I'm open to it. I don't have any strong opinions.
But I don't know what to call it because I just know configure await false is the thing that you do when your program stops
When you
working
really
and
want
you were a
async.
library.
It's when you really want async.
So we should call it dot really?
Stop, please.
only library writers. Still, when you are not cannot have specific context.
Yeah.
Well,
Well, still when you're
Perhaps have
not a
something
UI
like that, yeah.
threading
exactly.
thing. Yeah.
So does it only matter if people end up doing .result or .wait at the end to avoid deadlocks, or is it also for performance? Or is it...
There's a performance aspect as well. If you're if you're on something like the UI thread, imagine you were in your async enumerable, imagine you're doing a where async, and in there you were awaiting each item, and only 1% of them you end up yielding, right, out of your where. If you were doing that on the UI thread, every await is going to go back to the UI thread.
Yep.
But then if you expect to be on if you then update the UI after the last one, you need to be on the UI.
For the
thread.
1%.
Yeah.
You can come back after you're finished.
Yeah.
The code outside of it, when it's awaiting, it'll still be on the UI thread.
Right.
But the internal awaits that are happening, where 99% of them in that where example don't
Sure.
need to be, those are 99% of your posts back to the UI are happening unnecessarily. That said, link is an interesting question in general. Anytime you have a library, so the guidance is your library you use a configure await. You're not, you don't. But there's a weird part of the library one. You're a library and you accept a delegate.
Yeah.
What do you do? Because where does that delegate expect to be called?
So one thing we have with Signalar, because you can register callbacks. We don't run them on the sync context today. We run them on the thread pool where we are. And we've always done that, and most users are familiar with the idea that they need to do that, get back to the
That's the
UI.
reason we don't do configure await false in EF core at all, because we call user code all the time. And
See-
we have like half of the people hate us because we didn't flow the specific context, and the other half hate us because
You do.
Yeah, we in Signalar on the client, because the server is running an ASP.NET Core, we don't generally worry about it. But on the client, we actually, I don't think you can configure away that we cast on run right away. We just jump to the thread pool right away because of the likelihood that you're on a UI thread. We don't want to be doing our stuff on a UI thread.
Roslyn has an analyzer that requires you to set it for every await
But it
call.
feels something like .detach, maybe? I don't know, you're the domain.
But detach from what at that point?
The problem
You need
for
just
me
as
is
much
I'm-
research at that point.
I'm so like configure await false is just like a verb in my mind.
Yeah.
I just,
Indeed.
You got to configure await false it.
yeah.
Indeed. I am aware that is, that phrase is a word, configure await false.
Yes.
I can't wait till I find someone using.
It's like
configure await
conjugating in
true.
Arab.
Spend the whole day configure await
I've done it.
falsing.
You've done.
I've done it.
Oh.
You're completing the
Configure await true.
All right, so that's just a
Yeah.
thought for you, Steve.
Yeah, the entire IDE.
Yeah.
That's why we just require you to be explicit about it, because it's like if you're in the compiler, it's better be false, but if you're in
Oh,
the
I
IDE,
see.
it better be true.
I see. So I got it. Yeah, I see.
So not to like skirt work, but my default will be match the existing support that's there. I'm happy to do something different if people come up with a good suggestion. I just don't have one.
I wouldn't do something differently. If we do this, I would do the new overload as an
For all of
addition
them.
for both of them, and then you can do either model and then DL1. It's just don't. If you want to have it readable, don't do it. Well, otherwise, you have this weird jagged edge thing. which
Yeah,
is-
then it won't be discoverable for existing people who are used to it.
That's fair.
I think we also need you to come up with a name, because whatever name we choose is going to be inaccurate. So.
That's unfortunate.
So just move this method into task extensions as is, and
Okay. I can do that. All right.
So put it on task extension. Is that what you said?
Yeah.
assuming
I
that
guess
task
that-
extensions doesn't have a complicated, we've ended up ossifying the type due to like framework back chatter.
I mean, it's in core lib.
I just don't. I
Dispose
know that some of that we have types that are extension types that we now have the rule of we can't add anything into this because it
It's-
type forwards.
It's always been part of
places and-
whatever shared framework thing you want to call it. It's always been part of that. So.
So, I came late to the meeting. I apologize. Can I see the interface?
You have 14 minutes.
So, what is the cancellation story?
Ah.
Before, I'm just.
Yeah.
Let me just browse the interfaces.
Yeah, sure.
So this is also something that we've gone round and round and round about. Well, you'll notice that nothing on the screen accepts a cancellation token. And the reason for that is twofold. You can imagine two models. One model is move next async accepts a cancellation token.
Configure it.
Right. The other model is whatever you're doing that produces the enumerable accepts a cancellation token.
Right.
That latter one is our current path. So you just like today, you call a method and accepts a cancellation token. You write an async iterator. One of your arguments is a cancellation token. You use that cancellation token in your body, and so on. That, for the most part, that works really well. And one of the reasons that drove us there is, well, there are sort of two main reasons that drove us to that point. One is, in general, why would you pass a different cancellation token to every call to move next async? You're doing logically a single large operation with many subcomponents. It's difficult to think of scenarios where you would want different cancellation per call to move next async. I'm sure you can come up with some, but it would be very rare. The second issue is you write an async iterator,
and you're consuming it generally with for each async, how do you get a cancellation token from the for eaching into the body of the async iterator? You could solve the for each problem in two ways. You could either just not use for each and just manually use move next async, or you could have an extension method similar to configure await on the source enumerable, and that configure await or that whatever with cancellation method accepts a cancellation token and sort of funnels it through to the move next async calls based on the compiler's pattern generation. But then how does that cancellation token provided to move next async make it into the body of the iterator?
The thing that actually does the async operation.
Right, you've got your iterator, async, IAsync of enumerable of t, foo, async. And in this model, I see you're doing yield, blah, 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 yield, blah, 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 await, blah, 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 whatever, await. And that means that after, maybe there's another yield here, after each of these yields, there's a move next async call that's re-entering the state machine, potentially with a different cancellation token. What does that mean for the person writing this code, and how does the code in here even get access to that cancellation token? So we talked through various things we could do in the language, like having some sort of ambient context keyword that would give you access to stuff on the state machine, and it would put the cancellation token into there, and you can receive it.
I've seen languages
Value.
return it from the yield expression.
You could, the yield expression could return. You could do equals yield stuff, and that stuff could include the cancellation token that was passed to move next async. None of those seemed wonderful, and so the combination of all of that led us to say, well, the least evil thing would be just to pass it here. And that matches really nicely with existing methods. Use this here. The place it potentially breaks down is if you did have something like, link, and you didn't want to have to pass the cancellation token into the source of the asynchrony, like database call.select.where.foo. You pass the cancellation token into database call, and it sort of logically flows through. But if you didn't do that, if you did database call.select.where.foo, and then you wanted to for each with a cancellation token, you're kind of out of luck.
Right. So the other question I would have is like, what kind of types will we expect to implement IAsyncEnumerable, right? Because logically, async enumeration kind of implies there's communication to some extrinsic source. Otherwise, why would you make it async to begin with? So I can't, like, the typical thing where you have a collection doesn't make much sense in my opinion. So usually I would expect something like, I don't know, like the GitHub client that would have a pull request collection that is IAsyncEnumerable. But you could also just immediately expect those to be not just collections, you just make them methods and they just turn IAsyncEnumerable.
I think that was the point earlier, is
like
we don't expect anyone to implement this interface other than the compiler.
I would maybe even give servants saying guidelines like do not do that, like literally have methods that produce them.
Well,
because then you can actually have arguments being passed in. You can eventually add a cancellation token if you have. It just logically becomes an overload, like even when passing more state. Everything just flows from there. And like having types implemented seems like it almost like a bad idea.
Modulo the one conversion type from synchronous to asynchronous. Yeah.
Right. I mean, like wrapper types like link.
But that would just be the general, do not do this unless you think you understand why you should.
Yes.
So, a bit related question. Can I for each on the enumerator, not the enumerable? Because then I could pass the cancellation token to basically get async enumerator corresponding method. So in for each you basically say for each async var in foo.get enumerator, and I pass cancellation token.
Those are sort of logically separate questions. I think today you can't for each an enumerator.
Exactly.
Even if we allowed you to for each an async enumerator, it doesn't really.
It does, because then from get enumerator you pass the token to your async enumerator.
Sure, but how does it get into here?
You can't get into the generated method.
Well,
Or the
no, so
can't get into the method that's being generated as the statement.
yeah, I see, because I was thinking, because it returns basically what constitutes an async collection, but it's already created for you. I was thinking that this creates an async collection, but in the in the implementation you still
The biggest argument I've seen against this, and I don't necessarily buy it, but I understand it. My argument for this is 99.9% of the case when you get an enumerable today, you enumerate it once, right? It's one expression. It's I'm for eaching over get me an enumerable. There and in that model, this is totally fine.
Well, the iterator, the yield return state machine is not restartable, right? It's only able to be drained once, ever.
Well,
Well, you can drain
for
it.
the enumerator.
Yeah.
But the thing is, and this is what I'm saying, the enumerable, you can get as many enumerators from it as you want.
I'm just trying to think of
It's-
anyone that I've ever written and how they have
it's-
destructive side effects because they're reading forward. So reading it a second time is never
It's-
going to do anything.
It's
useful.
extremely, it's rare. That's what I'm saying. It's rare to get an enumerable, store it somewhere, and then for each that same enumerable instance multiple times. I've seen it happen. You can
mean
do it.
enumerator or enumerable?
No, enumerable.
If you take an IEnumerable, right,
Yeah.
and somebody wrote a link query that as a side effect does something, well, do you want to enumerate this multiple times? Probably not.
People for each enumerable
it is
multiple times all the time.
No, I would argue that
a list
not-
of
not
things
if
are
it's-
enumerable.
No, I would argue like if the thing is literally typed as IEnumerable, people generally try to avoid that.
And
If it's an object implementing IEnumerable that you know is static, like list of t, sure, you enumerate this a million times.
somewhere
but,
in the
like, that's-
things that put
that's- I would say
squiggles
it's
on my
different.
screen, something observes. You're iterating this thing twice. You have no idea what the second one did.
I'm
You
not
I guess
just
the
count
point
it as
is
a list.
that, part of the point is that while we do have lots of types that implement enumerable, and they're collections, and they're sort of like already materialized, so for those it's fine to like go over again and again, except if you mutate them, then it isn't. And then you blow up in weird ways. For asynchronous iteration, that doesn't really seem, I mean, it's async for a reason. It's async because you're waiting for it to materialize. They're not already materialized things.
Then why do we even have this IAsync enumerable? Why
Yeah.
not have just enumerator
Yeah, that's,
and allow for eaching over the numerator?
That is a fair question.
that's a fair question. The duplication, like the need to always to have this extra step, the interaction, if you will,
And you need to have
there-
extra time.
is there primarily for the purpose of being able to iterate multiple times. So I guess you could argue that.
So I
I
think
mean,
in
It would
I was
then
going to
move
say
into
it's not
like
that
try
uncommon.
get current because we would need to say both we're done looping and what the value is. But
It's not that uncommon to iterate over the same object. If you are using EF, for instance, you have a query object, and that query object you can iterate over.
I know you
many
can.
times. I mean,
Do people?
I'm willing
Is that-
to
is that
hear
the
the rest
common
of the
case?
argument, but I would say it's probably more than just 1 or 2%.
No, but
What's
you
the
will be able-
contract for them around, where do they start? Same, like, this, you start over, you get,
Yeah, you get
Run
the
the
new
query
enumerator.
again.
Basically, the current model in which you get an enumerator, and that's the thing that you cannot reuse, is perfect. Like, but the enumerable, you can reuse it. I mean,
We do that. I mean, we do this all the time in the compiler. We get a left, like this is overload resolution, right? We get a list of candidates. We see which is the best, and then, oh yeah, we have to go back through the second time and make sure that we got the unique best. So we for each.
but it's a
the same.
materialized collection at that
True.
point. What he's saying is he's actually running the query again.
Yeah.
so there are like some different scenarios. One is you have a base query object, then you add more link operators and you compose another query based on it, but you still keep the original one and then you execute both.
Well, what is your contract, for example, like one problem we have with enumerables regarding this, ignoring side effects for a second, you get brand new instances, right? So like, do I get back the same customer? Do I get back a new customer?
Well, that is tricky, but in general you get the same customer.
Because you already
all
have
the same
function.
DB context, you iterate twice and you get the same
Okay.
object, you get the same.
So you're saying that you see that it's common. So someone gets an object that represents select where, whatever. They store that somewhere, and then they come back to it later, and they grab that object, and for this operation they then do dot where dot select dot whatever, and they iterate that one, and then they come back to that same cache thing later, and they do dot select dot
So it
where on it
depends
again.
on the kind of application. If you are talking about the web application, that probably won't happen because in a request, you probably just construct the query and execute it. And,
Right.
But in a long living context, you can probably store the query, keep it somewhere, and then execute it again. I mean, it's not.
I know you
I'm not saying that
can.
it's super common, but
Okay.
I'm saying that it's probably a little bit more than 1 or 2%.
Well, the question, I mean, like, we're not proposing to removing it, right? The question is, should we also expose it from IAsyncEnumerable, right? Or could we get away with just one pattern where it's like, well, you get an instance, you can iterate it once, and then the instance is done.
I guess I'm trying to defend the existence of the IAsyncEnumerable because that's the thing that you use to get the IAsyncEnumerator. And
Yeah, but I think the question is like, are we doing it just because that's how IEnumerable worked? And sure, because we did it the way IEnumerable worked, some people are doing it. But the question is, if we would not allow this with this API, would we actually kill scenarios with that? Because it's like, it seems like, well, you could store it, but you could also just ask for it again. Right?
Well,
so I'm
and
trying to imagine what we would do in EF instead, and it's not easy.
Right. The reason that we bring this up is because it impacts the cancellation story. So
yeah,
you could imagine, so EF has to have custom implementation of all these things anyway, right? It knows about the concrete implementation of the I guess those are queryable, right?
We have queryable, and then when you iterate, you can iterate asynchronously
When you
with an
iterate.
extension method.
Yeah, but the things that you're holding onto are queryable, not
Yeah.
not enumerables.
Yep.
Yeah. Right. So that's sort of a separate issue. But even if they were enumerables, it would have to sort of logically understand all the concrete implementations that went into this because it's building up this huge, basically, database processor to and all that stuff. At which point, it could have a method called .with_cancellation that took an enumerable and returned an enumerable, and that added the cancellation token into whatever that stateful knowledgeable
That's the
thing was.
plan, basically. With this proposal, that's the plan. We'll flow the cancellation token into that object so that when you iterate, we know
Right.
how to flow it.
At which point that allows you you can store something, and then when you create a derivation of it, you can add the cancellation token and still have it affect the operation of the.
Yeah, and I guess if you want, on the second time you iterate, you can override the original cancellation token with a different one. But
you
that's
shouldn't
not
store
a
the
problem,
one with
not a big
cancellation because then if you cancel it and you go to iterate it again, it'll be
Right.
canceled.
That's the general argument about this: is if you have a source generator
Yeah.
and you don't put cancellation tokens into it,
Right.
then what do you do?
'Cause it definitely feels weird to me that if I were to call one of these, let's ignore the cancellation token. If I were to call enumerate something async, and I'm holding on this object, that enumerating it twice gives different results because, well, it did a second network query and it got different answers the
I
second
mean, it's
time.
the same thing. If you,
I mean, I know it's possible with everything right now, and this just goes back to the normal, like, the first thing that you do when you do this, if you need consistent state, is you drain it into a list.
Yeah, the expectation of enumerables today is that you've reached it twice, you get the same things, right?
That's what
But it depends.
humans expect, yes, not what the computers expect.
If
But yeah.
if the database has changed, you get a new set of
That's true,
results.
the data has changed.
But it depends on like whether the person who's writing the code expects at this point in my function and at this point in my function the cardinality of these enumerations is the same, and or the thing that was second is the thing that is second again. And yes, the answer is you drain it into a list, but it's still very yeah.
You're a bad person.
Mm-hmm.
But that's not the worst.
no, but I mean it's the same concept, and this shows up even in core libraries. File.readlines async gives you back an enumerable. Right? You can enumerate that enumerable any number of times, and every time you do it, it's based on the current state of the system. Which
Does
can
it
change.
reopen the file every single time you do that? Yeah, that's not fine. I mean, the only case where I wanted, like I have this side project of mine where I have a query engine, which is basically producing a bunch of, I call them iterators, which is very similar to enumerators. And so I have to create this query plan, right, which basically starts with reading the table, applying a predicate, joining something, blah, 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 right? And so the construction of this plan is moderately expensive, right, because you have to like do some optimizations. And so once you have the plan, you would really like to cache the plan, and then just next time somebody wants to get the rows, you just rerun this, right? But because my iterators are holding on to state, they're effectively dead after you did this. You have to redo the translation. So if the construction of the query, like the construction of the enumerables themselves, is expensive, I could see an argument for, you really want this as the unit of composition, because then you can just, yep, the translation from the IEnumerable to the IEnumerator is pretty straightforward. So that's just, you just allocate new resources for the new query, but you don't have to come up with the new tree of like what your query looks
But that
like.
means that IAsyncEnumerable get async enumerator is where the cancellation token should go.
Well, not necessarily. It means you have you can also have.
That's quite a jump.
Well, no, I agree with him, and that's what I was saying. If we allowed for each over enumerator, it would actually work.
And then
it wouldn't work with the yield syntax, but it would work
what the
as
generator
a way to pass cancellation token to
So,
followers.
I mean, what you would do. Oh, no, because you need it in both cases. Damn. Because that would just pass it into. Like, it would look like an input parameter to this, but it would actually come from the call to get async enumerator, but that doesn't work because you're already inside. Okay.
If you're,
One of the things we briefly discussed is that iterators should be able to have two parameter lists, one for the actual call to the method, and then one for the cancellation tokens. I don't know that will come in from whoever is iterating.
So, I mean, it's dirty, but properties, like a property setter and a getter, there's a magic keyword for the extra thing that you can't talk about in your signature. We could add a keyword for if we wanted to pass a cancellation token into get async enumerator, there could be this is the cancellation token that came from
that
async.
that was the idea about you have a keyword here that represents sort of the state that was passed into the next register. But even that is weird because the idea that the cancellation token can change. Let's say in here you enumerated something else. Let's say you did for each something else. You passed the cancellation token at the start of the enumeration as used for the rest of it. What if the person calling you changed the cancellation token halfway through their enumeration of you?
Well, I think that you would, it would look like value, it would look like a local. So when get async enumerator started, you got past your cancellation token, you're using it for your entire run. It doesn't change, so it's not in move next, it's in get enumerator, is my thinking.
Oh, that's your figure. Okay.
So you have a consistent token for your whole run. If you pass that token into something else, it has it for its whole run. You're all one token, but a second call to get enumerator might have a second token.
Sure, but that's no different than having something like this, which just bakes the cancellation token into the enumerable.
Okay, right.
So if you essentially what the with cancellation thing does is, yes, occasionally you have multi-use enumerables, but then you start out by creating a single use enumerable from it, and then you iterate that one.
So is that a thing we provide in the framework?
No, because there's no way, you have to know, in order to do that, you have to know you have to have internal knowledge of the implementation of that interface.
Because otherwise you can cancel the calls to move next, but you can't cancel the underlying
Which is
iteration.
true even if you pass a cancellation token into get async enumerator.
Right.
Okay. That feels...
Well, but that one is easier because you are implementing this method, so you know your internal implementation.
This feels really hard to get right.
This one too.
Oh, so that would not be an exception.
That's what I was saying,
It would be everybody implements that one. Oh, okay.
Yeah.
I missed that.
Yeah.
It feels really hard to get right.
So is that.
Well, except this one is a natural, that's what you do, correct? There are parameters to methods that create stuff, and then you stash it in a field, and you keep going. This one would have to have a blog post.
If it was, something inside if it was something like value, where there's now a new named thing that you can talk about that was never declared, and the engine just managed that, then that seems like, well, there's a pattern here. We're helping you with the pattern. We're doing the right thing. This is, you probably want to support cancellation tokens. We don't know which way you wanted to do them, and life is hard, so go write a million lines of code, and you're probably going to get it wrong. That's really what this feels like to me now that we're saying the word cancellation token now.
So I don't think that it's going to be that hard. It's not as hard as...
So we're 7 minutes over.
Knowing to flow the cancellation token.
I don't think we can close on the cancellation token in the next 3 minutes.
Right. And also, that path requires language support.
Yes.
Well, that's why I'm mostly looking at Mads while saying it. So
You mean, 7 minutes over. So we very carefully avoided doing anything with cancellation in the language the first time around with tasks. We're quite happy with that. And so if we were to do something in the language, it wouldn't be cancellation token specific. That will be along the lines of what Steve said. There will be some way that there could be some context that was ambiently available, and it would just happen, we just happen to define things so that a cancellation token would be there.
So I guess the other thing that would do it would be Christoph's suggestion of async for each. Maybe that's the first place that you can do for each over an enumerator, and then you can pass into the enumerator, or into get async enumerator something, and then. But now we need the state machine to work nicely with
Well,
saying it wants to yield return into an
Well,
enumerator,
So
which is a
that
one
works
shot.
very nicely. Correct me if I'm wrong. It works very nicely if I basically manually implement this interface. I don't use yield. I mean, it seems
So-
like it's better than nothing.
Iterators in C# today can produce enumerators instead of enumerables if you want to. I mean, just change the return type to that interface, and then people use that. If they are manually implementing an IEnumerable, they often use an iterator to implement the getEnumerator method on it.
Well, but can you then pass this parameter? So I now manually implement getEnumerator. It takes a cancellation token. Can I pass it to the enumerator created by the yield statement? No.
But
It basically just kicks the
It wouldn't be
can.
part of the interface,
with
but you
the
can certainly do it.
with the
Yeah,
language
but-
support that's being added for this, can I declare or can I make
How would you pass it?
an IAsyncEnumerable using the state machine generator, or does it only do enumerable and return this?
I believe you can also do this one with enumerators.
So I think so. Then it sounds just like the cancellation tokens. Well, then the problem we're back to you want to write async for each, and for each would need to, or you wrap it with your own enumerable, I guess.
Right. I guess the question is, do we want to make
Yeah, and now I implement.
enumerator an sort of a currency type, an
This
exchange type,
works. You can
just
write
like
this
enumerable is today.
Public IEnumerator, getEnumerator, it takes any arguments you want. It doesn't implement the interface, it's an overload of the interface method.
Because it sort of speaks more, especially
Well,
for
Inside
destructive.
this implementation,
Yeah.
I use, now I can use yield and I basically just inspect the token, correct?
Yeah.
How do I now expose it? Basically get enumerator method.
But you would
This
call
one.
this and then for each, but I don't think you can do that today.
Yeah, you can move
Can't
next-
for
you
each.
can manually.
You'd have to manually move next it.
Yeah. This is implemented on an enumerable,
Yeah.
and this would be a public.
Oh, yeah. Okay, yeah.
And it would,
So that would
if you
work.
want to use yield, well, if you want to use async and yield, it would be, well, never mind.
Well, but if it supports IAsync, or you implementing directly IAsyncEnumerator of T with the yield or async yield
Yeah.
combination, then if you wanted it to be, so then that could take the cancellation token, you wrap that with your own IAsyncEnumerable, which
Exactly.
defers to calling
Yes.
the one with
It
the.
all
It
works.
actually creates a new protocol of saying, like, you return an IEnumerator when you're one-time use, enumerable when you can be repeated.
Yeah.
Like, it's not bad.
Um,
Like,
and so we
clarity.
would, just need to clarity that with cancellation token and what looks like the right thing to do. And it seems like, if you think that's the right thing to do,
Although,
as the person
if you
who knows
store
how
the
this works.
Sorry, I didn't
enumerator for
understand
each
what is being
twice.
suggested.
So you would
It's bad.
take it as an input parameter, but instead of returning enumerable, you return enumerator, and then we have the pattern for here's how you wrap a cancelable enumerator with a enumerable, so it can still be passed as the exchange type. Or we say, dear language team, you have a couple weeks left. Let's get for each over enumerators. So. But it feels like this is solvable with the one, like making enumerator be more of a pattern of this is a one-shot call, calling it a second time is different, right?
And
But
by
it's
the way,
obvious.
this problem of not being able to, you are probably aware, of not being able to enumerate enumerators. It's kind of it comes up from time to time because you want to have one collection and then, two different ways to enumerate it. You want, forward and backwards, let's say. It would be nice if getEnumerator took a Boolean parameter backwards and then I can just for each. Today I cannot for each over it.
It's a bit of a risk if you allow that, if you for each it twice.
Well,
If you take the enumerator, store it in a variable,
mhm.
for each it, and then exit for each, and then for each it again.
Yeah, well, but
You would have to
So our even existing implementations don't allow you to do it. What do you mean for each?
Well, the
After for
enumerator
each
is
dispose.
local to the. Normally, the enumerable is what you pass in. The enumerator is created
Yeah.
in the for each,
Yeah.
and you can't access it again after the end.
Yeah,
of
yeah,
for each.
exactly.
Right.
Yeah, exactly.
But
So it
but
would
you
be no
would be
change.
able to here, if you allowed for eaching over an enumerator.
Yeah, but it's well defined, right?
Because you pass it in.
If we allow an enumerator, who's responsible for disposing?
You will for each the remainder until you
Right.
out of the-
Well, except
The
for
enumerator?
each would have disposed. Of.
After the end of the for each, it gets disposed.
So the for each would, even if you,
So
you
the
pass
second
it
for
through
each-
it, and
the
probably
second
you are
for each-
managing it, the for
That's
each
true,
is
the
responsible.
disposal thing.
The
Sorry,
second for
both
each
of you were
would.
talking. I
sorry.
didn't hear.
So in general, like I like the pattern in which if I pass an object, if I create an object, then I'm responsible. And if I pass an enumerator to for each, and for
We
each
do
is
it
going to
today.
dispose it.
Today, for loop calls dispose at the end.
Right, but
No,
I
for
didn't
each-
create the
it
enumerator.
created
But
the
it creates
Ah, I
a
see what you're saying.
But the IEnumerator, this one doesn't, but IEnumerator has a second parameter, or a third method called reset.
Which we always
which always
implement as
throws.
not supported
No,
exception.
I know, I'm saying that's the trap, right? Like that
Yeah.
Well,
the way around this is to reset it,
Right.
which will never work in any of the current implementations.
we had a method to communicate that it's not possible to
Can
do.
reset.
Can reset? No.
So we're not going to finish this now, but Matt's an
All right.
like, what's the? Is there a?
So like, let me just summarize. So basically, so we talked about the interfaces, right? So the modular cancellation, I heard no pushback on the interfaces, the shapes, the namespaces, the composition we had there. There's I think some work. I mean the other thing we talked about was to configure weight stuff, which we basically said we will have an extension method that does that to be consistent with what we have. And I think the major work that seems to be left is like figuring out whether we're happy with the cancellation model as it's proposed here, or whether we need something different, which now might actually change the shape of the interfaces.
The only thing it would, if we were to do anything with cancellation, the only thing it would impact is adding cancellation token into one of those parentheses up there.
Right.
But I completely agree with you. Adding it to the second parentheses, meaning to move it next async, is kind of clunky and potentially bug prone.
And are you
I
likely
would
to
not do it.
cancel and then move next again? And generally, you're canceling the whole iteration. You're not canceling one step of
Exactly.
it.
It seems very good to do it on a call-by-call basis.
So the question is whether IAsyncEnumerable takes a cancellation token, and if it does, how it ends up inside the iterator. Which
Yeah, what is the problem with the current proposal? It just feels iffy that it's stored in the enumerable, not the enumerator.
that's the general concern. Is if it's a single-use enumerable, there's zero problem. If it's a multi-use enumerable, what does it mean to have the cancellations token stored inside?
Right.
And then you can easily work around that by producing a new enumerable that has the cancellation token stored inside. But in order to do that, you have to have white box knowledge of the source enumerable as well.
Essentially, I mean, one way to kind of close this would be to say that, okay, we say that single-use enumerables are the common case. If you have a multi-use IAsyncEnumerable, then we encourage you to offer the facility on that thing, on that class, to pass in a cancellation token and get a single-use one that you can for each that will respect that cancellation.
Well, but I
And
would
that
say,
seems to be that's the lowest friction approach to that problem that I've heard.
but I think we already have a pattern. Enumerator is a single use.
No, but the enumerator has all these other problems. Like, who disposes it then? If it becomes a currency type, who then consumes it and says, "Oh, I consumed it," and how do you maintain that contract across method boundaries?
And if you exit out halfway through enumerating it, like, do you break in the middle of your for each? Does it dispose it or not? Well, if it created it, then yes. But if it didn't create it,
Yeah, maybe somebody else is going to do the rest of the for eaching.
I don't know. There are problems in both cases.
So it opens a can of worms that
I'm comfortable saying that you provide a way to associate the cancellation token with your IAsyncEnumerable. It doesn't need to be a single-use one. Even you just associate it, and you can keep it and
Sure.
cancel it later.
Yeah, it doesn't have to be single use. It's just that you would probably only keep using it for as long as you're happy with the cancellation token you gave it.
It becomes single use because imagine somebody for eaches and cancel happens. Can you for each it again?
Well,
Or it's cancelled.
Oh, but
Or it's
your
permanently
multiple
cancelled.
for eaches might be part of the same overall operation, and the cancellation token is shared. I mean, that might be fine. That's up to you.
No, but is it
Like, do you
permanent?
check one out and use it multiple times? Whoever checks it out with a cancellation token, whoever gets sort of the cancellation token enabled version, it's up to them how many times they will for each it and whatnot.
No, but once it's cancelled, is the collection dead? Like you now
No,
cannot
it
for
shouldn't.
each
Yeah,
it because it's
IAsyncEnumerable shouldn't
permanently
be.
cancelled because the cancellation token is in the
Then
collection.
that tear off version of it is dead. Yeah, but the core like base collection is not dead. It's not. It's a multi-use. If it's a genuine multi-use enumerable or async enumerable, it'll keep working. You can come up to it with another cancellation token and say, give me another wrapped
just
enumerable
quickly,
that I
can
can
you
reach.
open the issues list and search for me as author? For Cortex. And go to, keep going, this one. So a channel is logically the closest thing we have to a collection that is asynchronous. And forget this guy for a second. But if every time I want to enumerate stuff from the channel, I just call for each or await for each blah channel.asAsyncEnumerable, and I give it the cancellation token that I want to use for that enumeration. I'm effectively tearing off whatever you want to call it, an enumerable or enumerator. The channel reader is multi-use. Any number of people can be enumerating it. But if I want to supply cancellation, I get an enumerable that has my cancellation token, and I enumerate that. And then when I'm done, this cancellation token hasn't affected the channel anymore.
Yeah, it's just to me. So this is the case that I was kind of saying. Well, it could as well return enumerator. It would be exactly the same, and then you bring up the issue of disposing, and I'm like, well, here you kind of, it's equivalent, correct? Who disposes this thing after it's being enumerated?
Whoever called get enumerator on.
Exactly.
Enumerable is not disposed.
It doesn't need to be disposed, but the enumerator coming from it does, and that's whoever for eaches it.
I think his argument is that if you have
It's the same, it's a wash, right?
async enumerable with a cancellation token, right? The problem of that multi-use IEnumerable is that it's only multi-use for the lifetime of this cancellation token, right? As soon as that cancellation token is done, that thing is also done.
Yes.
So in
but
that
I
sense,
call
it's
this-
not true multi-read.
No,
So it's
the channel reader is multi-read. The IAsyncEnumerable is Mads is let's tear off a single use.
Yeah, like all Chris was pointing out that you have the equivalent problem in the sense that you have something that is multi-use, except that it's not clear what the scope of the multi-use is.
Right. The different you're trying to say that a single-use enumerable is really just an enumerator,
Exactly.
and that's true to an extent. It's an enumerator. It's kind of equivalent to an enumerator that hasn't been started yet, right? An enumerator is more than an enumerator can exist in a state where it's half iterated,
Yeah.
and you don't. So you kind of want single-use things that aren't started yet, and they're sort of in between. They're not quite enumerator because they're in a pristine, uniterated state,
Yeah.
and so you don't have to worry about any disposal yet. But they're single use, so they're not quite enumerables either.
And so I agree with you that logically there are those three concepts, correct?
Right.
I just wonder, like, geez, we would not be adding the third concept. I hope you're not proposing that we add the third one.
Yeah. Now you.
So then I'm saying, like, geez, there's an issue with the dispose. I understand that, but enumerator seems to me closer. It would be easier for people to explain what's going on. We would basically say the reset thing was a feature. We now implement reset as throws not supported exception, meaning enumerators are single use, enumerables are multi-use.
I just think I get what you're saying.
If you use language syntax, we will dispose it for you. If you don't use language syntax, you dispose it.
Yeah. My counter argument would be that, as pointed out earlier, right, the scope of the cancellation token is usually much larger than the scope of a single iteration, right? It's completely fine to say within your async iterator to say I enumerate this thing once, do something, and then do it again, because I'm part of the same cancellation of the overall operation.
That
right?
would work in both cases.
Well, except when the only thing you have is an enumerator, you can only do it once for sure.
No, but the cancellation token applies to each iteration of the rule. I thought that's what you wanted.
No, what I'm
That's
saying
still
is
true.
that you're within, like, basically, if we do what you suggest, the IAsync enumerator becomes the thing that people deal with, right? Now I'm within my my async iterator, and all I want to do is I want to iterate this thing once, compute something, iterate it again, and do something with that knowledge, right? Given that this whole thing runs with the same cancellation token, that's fine if everything is IAsyncEnumerable, because I can iterate them as many times as I want, so long as they have the same cancellation token, which I know by construction is the case in my case. If the only thing I have is an enumerator, I can only do it once, and if I want to do it again, I better store it somewhere on the side, so I have to allocate an array or something, and then I can enumerate this again, right? So you basically make that common case, I would argue, harder. Because I think the cancellation token in practice will have a lifetime that is
Enumerating async
long
streams
enough.
twice will be common. Is that what you're saying?
No, I'm saying that the common thing you have today is that when people think in IAsyncEnumerable, they can generally iterate it multiple times, and with the even with the cancellation token restriction, that will hold often enough.
I'm just saying, like, people
That
should
is-
not be doing this with async streams, in my opinion. Like, it was a
I would
fine
argue that's an
optimization for
orthogonal
in-memory
thing.
collections. Like, I enumerated twice, so I first determine the size, then I create an array, and then copy. With async things, I don't know if you want to do that.
I fully, look,
I agree with
I
that, too.
fully agree with you that there's something that that an enumerable is a little too heavyweight for this thing. I just think it is what it is, that we have this concept in the middle of an enumerable that's only supposed to be iterated once, but you haven't started doing it yet, right? And it can be you want something that can be a currency type, and you can't have a currency type that is mutable and in the middle of a transformation, right? So that's why enumerators aren't good as a currency type, but you could have something less than enumerable. It's just that both you and I agree that we don't want to add this third thing.
Yeah.
You could have, I mean,
But you can kinda have a
what would
convention,
the
right?
third thing, what would that look like? It would essentially be a thing that you call something not called getEnumerator, and you get the stateful thing that needs to be disposed. But if you call getEnumerator again, you get an exception. That would essentially be the intent.
I was about to say, like, you can literally just implement it like that, right? You can just say it's IAsyncEnumerable with the additional contract that you can only do it once, and then I throw an exception. It's exactly the same as reset throwing, right?
If you want to protect consumers, you kind of need the indirection before you get the stateful object that they could accidentally share and do crazy things with.
Yeah, the question is, like, ignoring cancellation token. Does anybody believe there will be more state-like cancellation token that we need to think about?
Well, state that you need to read inside your implementation or in general? Because as I said, I've seen cases where people were saying it would be nice if I could for each collection forward and back, or skip every third item. Well, it would be nice if we could pass parameters to, get enumerator methods. And then the method creates kind of a enumerator in a different mode in each of the cases.
Right. Yeah, which makes it problematic for the interface, though, right?
Get enumerator factory.
Well, it only makes it problematic for the interface if
What is an enumerator factory called?
you cannot.
Enumerable.
You mean the interface existing one or the new one?
Well, anyone, right? Because we can only have a fixed number of arguments in the interface. We have to decide what they are.
What do you mean fixed? Oh, I see. You were saying we won't be able to add more.
Why? You have to
Is that
decide
what
what the fixed argument is you can pass to it, right? I mean, you can make an object state and then say what
event args, something that derives from event args.
Yes. Something
But
like
all of that can be solved by passing something to the IAsyncEnumerable and get another IAsyncEnumerable that knows about that state, which is the pattern that.
Right, which is exactly what this IAsyncEnumerable is, right? It's effectively it's being given the channel reader
Right.
and a cancellation token and producing a new enumerable that knows how to use one with the other.
Right. And we are creating new enumerables derived from other IAsyncEnumerables all the time. Like Link does that.
Yeah. And I agree with you that it can be solved with this. And what I'm saying is, it can also be solved with creating different enumerators. And if we did for each, and I did the dispose thing, I have to tell you, I kind of don't buy the. I understand that there's a dispose issue and you can screw it up. I'm not sure if in practice it matters.
So I think that the core of where I agree with you is basically it feels natural that the thing that you are trying to cancel is the enumeration.
Yeah, which is done
so
by the enumerator.
enumerator would work for that reason, but it doesn't work for many other reasons.
In a certain sense, I don't disagree with you. I just don't think we can do better. I don't think we can go back on that, and especially not. The additional thing also is that even if we did it differently in the async space, we would now have inconsistent models between the two, and that's
Speaking
vastly.
of, okay, now one more thing. If we have 5 minutes, I will just ask a question.
We have an hour.
Did you
Minus
consider
is
not having to move next and current? I mean, maybe for async it's not, significant to worry about it. But for our existing collections, like I implemented like a for each that basically with one call try get next.
We considered
It's
about
so much faster in a lot of cases where it's like it's just an array list of t.
Yeah, we had a huge
becomes so much faster.
we considered about 9 or 10 different variations of this.
Yeah.
We actually implemented up until a few weeks ago a completely different approach in the compiler. There are various constraints around what you can do asynchronously with regards to ref and out. What you can do with regards to co and contravariance. And we had an API that allowed you to basically, the alternative, sort of the winning alternative was basically a 2-method interface, wait for next async, and try get next.
Mm-hmm.
And basically, you would effectively start the state machine moving forward, and then once there was something available, you would sit in a tight inner loop calling try get next.
You cannot have one method because of the out parameters.
Yeah.
And I see. That's a good point.
But we tried really hard.
Then it was less than
Yeah.
5 minutes.
All right. You want to do lunch, Krista, or do you have something
Yes.
else? All right.
Thank you all.
Thanks.
So first, guys, things online.